Hi there, I hope you're doing good and welcome to this most comprehensive Python course on YouTube. This is almost 14-hour course where I have talked about the different aspects of the data analysis, data engineering and data science techniques within this one single course. So this course, as you can see, is all about data analysis within the Python, and we have used the very famous data science integrated development environment Jupyter from Anaconda. So if you're looking for building your skill right from the scratch, make sure that you watch the video right from the scratch to the end, because my objective is to give you the maximum knowledge which will give you up and running, or which will get you up and running into the Python for data analysis task. Or if you are an experienced programmer and looking for a solution on a particular topic, there are a lot of videos that I have covered in this entire tutorial, and about that particular topic you can get to know within the description and jump directly to it. So it doesn't really matter whether you have done previously any coding within the Python or not. You are very much welcome to join this course and start learning the Python from scratch. And before we dive in, I would recommend that you subscribe to my channel and subscribe to all notification by pressing the bell icon, because I will be sharing a lot of comprehensive tutorials in coming months, and I just want that you are getting the maximum knowledge from my channel. And it's always good to share the stuff with others, so don't forget to share this video with your friends and colleagues so that they can also utilize and maximize their knowledge within the technologies that I'm teaching. And if you have any question or comments, do post it in the comment section so that I'm replying to those based on the queries that you have. So let's go and get ahead with Python. Alright, so the first step that we have in starting any machine learning or data analysis within the Python is to get the integrated development environment, or in this case Jupyter Notebook. So Jupyter Notebook is something which is given to us by Anaconda, and the website name, as you can see, is anaconda.com. So from this website, what you can do is go to this download option. Once you click on the download, the information is given to you about Anaconda distribution first of all, and it's saying that the world's most popular Python art data science platform, and that's absolutely, in my view, it is right, because I really like coding in Anaconda or in Jupyter Notebook as compared to any other. And as you can see, it comes up, or by default it downloads and installs all of these different libraries like numpy, scipy, bokeh, dask, pandas, very important. Pandas and numpy is like absolutely important, and then matplotlib for visualization, and sci-kit learn is something which you need for machine learning, and all of that is available by default to you. You don't have to worry about any other installation, and that's like covering up almost 95 to 99% of your task and everything which I will be doing in this course. So first option is that for Mac OS, if you want the installation, you can get it, or for Windows, if you want, you can get the Windows version 3.7 and 2.7. Recommendation is that you get it 3.7. So once you click on the download option, and that is for Windows, as you can see I've selected that, it will ask you where do you want to save it, and as you can see it is a simple Windows application, any other application that you might have downloaded or installed it earlier. So maybe within the download you can click on download and click save, and it will take some time. As you can see, it is 486 MB. In my case it is taking like somewhere around 30 seconds, so it depends on your internet speed about how much time it will going to take. But once it is downloaded and installed, you can install it by clicking it over here, and the instructions are pretty much the standard instruction, which is like accepting all these standard settings. That's something which is recommended by Anaconda, until unless you are really sure that you want some custom settings. So in this case now Once, as you can see, it is downloaded, but since I have already installed, so I will not go ahead and do the installation. In my case, I have accepted all the standard libraries, all the standard settings, and that's what I will recommend for any beginner like you, that you go ahead and install, whether on Windows or on Mac OS or on Linux, with your standard settings. And once it is there, once it is downloaded and installed, what you can do is go into the start. As you can see, I'm using Jupyter, the Windows 10, so I will say Jyputer, or I can say Anaconda, and over here I get the options for different Anaconda, like Anaconda Navigator, Anaconda Cloud, and Anaconda distribution, which I just downloaded. So it's basically JUPY, so JUPY, and here is the Jupyter notebook, which I will be using in my entire this course. So once I click over here, you will see that a command prompt has come, which is basically invoking the session. And as you can see, it is a web-based session that is given by Anaconda. And over here you can see that there are multiple folders that I have created. So how you can do that is by coming over here, click new and folder, or if you directly want to create a Python file from the same new option, you can create a Python file. Once you click it over here, a new Python file will be opened for you, and its name, you can click over here and change the name, my first Python file, or whatever name that you want to give, or first underscore program. Okay, so this is something which is now renamed, and you can start coding right from here. And in the upcoming videos, you will see that we are importing the file, which is a process for working with any data science project, and then manipulating that file, visualizing that file, applying machine learning algorithms, so on and so forth. All that list you can find it there in the description if you directly want to jump on anything. And then finally, the last thing, the one mistake which even the experienced programmer up until like some time back, even I have done that, is simply closing the Jupyter notebook, which you should not do. What you need to do, whenever you are done with your program or you want to close your program, come to the file and click on close and halt. And the reason is that if you are closing it directly from here, it will close the tab, but it will not close the file or the processes that it is running within the file. And because of that, it may happen that your system or your file is using a lot of systems memory or your server's resources. So always recommend that you go in file and click on close and halt. So that's about it, and let's start our journey by importing the data in the next video. Alright, so let's dive into the Python programming, and before we actually start importing the data science files and do the data science stuff like manipulating data, processing data, fitting the algorithm, visualizing it, all the sort of processes, before that, let's start with complete basics. So the first thing is that you apply all these processing either on the numeric data or on the character data. And here I am in the Python Jupyter notebook, as you can see, and we will see some of those data types if you are not at all familiar with that. So for example, if you see that this is the place where I can write the code, and how I can know that is by using this particular drop down where it says that I am writing a code, and then markdown is something where you, let's say you want to make a note or something, heading is something where you want to give a heading about what you are doing. So for now we are in a code mode, so what I can do is I can just write 2, let's say integer value or a numeric value, and to execute this I have two options. One is control plus enter. I am on a Windows machine, so I am giving that instruction. So control enter. So if I press control enter, as you can see, it has given me the output of 2. So there is nothing fancy going on. It's just that I entered 2. The Python interpreter understand that what I have written and gave me the output accordingly. So control enter is the first option to execute. Another option is shift enter. So what's the difference? Control enter just gives you the output. Shift enter gives you the output along with it creates a new line for a new code. So now I am going to execute it again with the shift enter. So if I press shift enter, it has executed, as you can see, and it has given me a new line. So now I want to, let's say, write something into the string or something related to the character data. So one of the very famous program, as you all know, when we start programming is hello world. So what I can do is simply write hello world and press shift enter. It has given us the string hello world. That's it. Whatever we are giving to the Python interpreter, it is interpreting it and giving us the output. Or what we can do is use the print function as well. Within that, we can say, hey, print function, print the hello world. And if I press shift enter, the hello world is printed. The only difference is the print properly interprets it and gives us the output without any single quotation, as you can see the difference. Now, so this is about the integer and string. We also have float values. So like 2.02. This is a float value. So any value which is having a values after the decimal point. So decimal point is this. After decimal point we have 02. This basically makes it a float value. So very useful and very important when you do the complex operation, and even a decimal point values makes a lot of difference. So when we press Control or Shift Enter, again it just gives us the output. So how about adding up a number, dividing a number, subtracting it and whatnot, what we can do with Python. So it's like a calculator. So let's say I want to add 256 plus 375, any random number that I have taken, and I press Shift Enter, it gives us the output. Now let's say if I want to multiply this, 256 multiplied by 375. So the only difference, as you can see, is I have given a space, and here I have not given any space. It doesn't really matter at all. So just it looks much better, not very congested. Shift Enter, it gives us the output. Similarly, if I say 256 divided by 375 and Shift Enter, it gives us the division. Similarly, if I, let's say, 265 again minus 375, Shift Enter, minus 110. So whatever operation, whatever calculation that we are giving it to it, it will going to execute that particular mathematical operation. Now after that, let's jump on to the variables part. And variables, if you have not at all heard about it, it basically holds the value so that you can reuse it again within a long program. So why? Because let's say, for example, 256 is basically the quantity that needs to be used at multiple places in a entire program. Let's say you are writing a program for order management, and in that you need to calculate the quantity, and you need to sometimes multiply it with the number of orders, or to identify the discounting and whatnot. So for multiple calculations, what we can do is we can store the values in a variable that can be used again and again into the program, so that we don't really have to use a particular number like 256 or 265, what I have given here. Another benefit is that once you declare the variable, so for example, let's say quantity equals to 265. Now let's say tomorrow I want to calculate the value or sales value, discount value, average order value based on a different quantity. So what I can do is I can simply change it to, let's say, 300. So this way I will not have to make the changes at, let's say, 15 different places if I am using this variable in a program. Just change it at once, and wherever the quantity, this particular variable in which the value is stored, and it's stored using this operator, equal to operator. So now if I press Shift Enter, nothing is printed because that's not what we have given. And if we want to print it, what we can enter is quantity, quantity variable, press shift enter, and you will get 300. Similarly, for string like hello world, so I can write first underscore program, and that's the way you basically create the variable. So here this is a single word, that's why there is no underscore or no special character that I have given. But this first underscore program, if I don't have the underscore, it looks a bit clumsy and sometimes confuses us. So to better write it, we use most of the time first underscore program or quantity underscore month, variable like this, which makes sense. So first program is hello world, and if I press shift enter, nothing happens. But if I write, let's say, first underscore program and press shift enter, it gives us the output. So the idea is that variables holds the value that you are giving, and when the variables are used in a program at multiple places, you always have the option that you can change the variable either coming into the program, or you can give the user input to the front end through which they can play around and give the output as per the needs or the business analysis that they are doing. So a quick example is the BMI, the body mass index calculation that we usually have in the health centers. So what the calculation basically says is BMI equals to weight divided by height in meters and square, right? So this is the calculation that we have. So this basically indicates the square. So how you can get to know about it? Now I will not execute it because this will give us an error, but just to give you an idea about this particular operation, what I will going to do is press escape once so that I am not in edit mode. As you can see, my cursor is gone, and I will press the shortcut B, and it will create a new line below the current line. So to create a line below the current line, press B. B is B for Bombay. And to create it, the line above the current line, press A, right? So here we will say 2 and 2 stars 2. If I press Control Enter, it gives us 4. So it's nothing but the square. All right. So what I want to do is I want to first create weight equals to, let's say the weight is 70 kg. And I press shift enter, and height is, let's say, 1.79 meters, and I press shift enter. All right, I did not write the equals to sign. Shift enter, and now I can say BMI equals to weight divided by height cap 2 or square 2. Press shift enter. Now it has not given us any error, and I can go ahead and see the BMI and press shift enter, and the BMI value is this. And based on what your height is, what your weight is, the different BMI values comes, and that's a very common operation. If you have seen the particular instrument which calculates BMI, you have to stand up upon that. It calculates your weight, and you manually need to enter the your height, and it gives you what is your BMI index. And based on the standard, you can see whether your body mass index is in your favor or not, and accordingly sometimes even medicine is given. So now let's say there is another patient which is coming. The weight is, let's say, 85 and height is let's say 1.10. So what we need to do is after entering it, we need to press Control Enter. So I'm executing it, coming on to this, Control Enter again, Control Enter again, and now the BMI is 70. So this way you can see that once I have written the formula, I just have to keep on changing the variable, and that's what you see even in a device, that it just asks you the new values all the time, and your program keeps calculating the new value for you. So that's a program that you have created, a very, very important BMI index, right? Now what I want you to do as an exercise, which is again a very simple exercise. So suppose you are part of a hotel and responsible for developing a program to calculate the room charged based on the number of rooms a customer wants, multiply with the occupancy days, number of occupancy or occupancy underscore days. So one variable is number of rooms that they want, another one is occupancy days, and then third is charge per room. Very simple exercise. You need to create 3 variables like I have done it over here, and then calculate the room charge every time a new customer is coming, and the number of rooms, the number of occupancy days, and the charge per room that you need to charge to that customer, and it should keep giving you the new calculation based on the situation that customer is having with you. So that's about it, some of the basics. In the next video we will move on with importing the files. We will see at different types of imports, and then we will move on to pandas for data manipulation, and then to matplotlib, and then to machine learning, and a lot of applications for a day-to-day working into a data science program. So stay tuned for that. There is a lot that I have covered in these multi-part series of around 18 hours of lectures that I have created. So overall I will publish like 6 hours tutorial in 3 parts, and you will get the maximum value out of this. And make sure you comment about your experience, what you like, what you did not like, and I will reply to your comments. Hi guys, this is Abhishek, and from this video I am starting a series on Python Pandas tutorial. So probably most of you are already aware about Python Pandas, but if you are not aware, then Python Pandas are basically a very famous library for doing the data manipulation, like importing your data from various sources, merging it, manipulating it, and putting it in a structure so that you can further do the data science work. So here we will start with a very basic about how you can import your data into the CSV, and in a step-by-step in this series we will going to cover the more complex topic. So first of all, let's go ahead and talk about how you can import the CSV data into Python, and exploring their couple of options when you are loading the data. So first thing is importing the pandas libraries. So import pandas as PD. So what I'm using is basically a Jupyter notebook, which is a part of Anaconda distribution, and by default this pandas library is coming with this. So if you are using the Anaconda distribution, you will be getting this, and I will highly recommend that you use the Jupyter notebook because it comes with all the default settings which probably you as a beginner need without going much into the complexity about what are all the libraries you need or don't need. So go for Anaconda as a search term in Google, and you will find the Anaconda distribution for Python, and just go ahead and install it, and you will find the Jupyter as an icon in your start program if you are using Windows. Alright, so first thing is importing pandas as PD. So let's go ahead and execute this, and once you execute this we need to use the function read underscore CSV. So as you have seen, we have import the pandas as PD. So as PD is basically giving an alias to pandas library so that we don't have to write a long name as pandas. And here in the second statement we are creating an object Nifty, which is a trade index over here in India, which contains top 50 stocks. And what we are asking is basically to read a file from our desktop location. So PD dot read underscore CSV is a function which is a part of the pandas library, and then we are simply giving the path nifty data.csv. So this file is already on my desktop, and I will share the link with you in the description for this particular file. And then the next statement over here we are using is nifty.head. So head is nothing but it shows first initial observation, around 5 or 6 observations about the entire data set, so that you can get an idea about what you have loaded and review it, whether everything is not everything, but at least all the columns have been loaded properly at least. So let's go ahead and execute this. So if we execute this, as you can see, it's pretty fast, even though the file size is small, so it has to be fast. So here we have loaded the data with the help of this command and giving the file name niftydata.csv and then nifty.head, and you can see the 5 observation. So this is the index, the 0, 1, 2, 3 and 4, which is given by default because we have not specified anything as an index. So a numbering has been given to you, and then the date column and the close column, which is part of this file. That means on this date, this was the closing price of this index. Right. Next thing is, generally a CSV file is a comma separated value file, as the name stands for, comma separated value. But you can use the option or a parameter of read underscore CSV along with your path name. You can use this parameter SEP, which is nothing but a separator. So separator can be comma, which is a default choice, but if you are looking at your file and you see that it's not a comma but a pipe, let's say, then you can give even pipe or tilde or anything else, which is separating your values. So you can use the SEP, the separator argument of this function, and get your data in a proper format if it is not just the comma. So let's go ahead and execute this, and as you can see, again the output will be same with the head command. So let's go ahead and see the another parameter, which is n rows. N rows is basically helpful. Let's say you are having a file of of a GB or a multiple GBs file, like 3 GB, 5 GB file, and it is taking a lot of time, and while loading, you see that there are some issues with the file. So what you can do is you can load some initial observations like 1000 observation or 10,000 observations, which will give you an indication whether there is a problem with the file or not. So in that case, if you want to limit the number of rows that you are importing into the Python within this object nifty, then you can use this n rows parameter. So if I go ahead and execute this and show the entire object, so if you see this time I'm not using head like I have used it over here to show the first 5 observation. I'm basically trying to show the entire observations. So if I go ahead and execute this, it will show you all the 20 observation. So from 0 to 19, if I show you from 0 to 19, all the 20 observation. If you want, you can change the n rows to from 20 to 200 to 2000 based on the experiment that you want to do and the number of rows that you want for that experiment. Alright, let's go ahead and see the next parameter. The next parameter is header. Sometimes your file is not having any header, and in that case you can specify header is equals to none, and by default, like index, the header value will be given as 0, 1, 2, 3, depends on the number of columns that you have. So let's go ahead and adjust our file a little bit. So for example, we have this nifty data, and let's remove this row and let's delete this. Alright, we have just removed our headers to create these examples, and let's see the file in action. Alright, so let's go ahead and execute this piece, and here you can see the file is loaded, but the header has been given as 0 and 1. Let's see what happens in case of this parameter is not given. So if I execute it again by pressing shift enter, the name of the first observation have been taken as the header of this data set, which is not correct. That is why it is important that you give header is equals to none, and then the observation will come as it is, and header values will be 0 and 1. So that's why whenever your data set or the file is not having any header, please give this header is equals to none. Now Once we have given the header is equals to none, but still you want to give some business friendly name or analysis friendly name for your analysis so that you can better remember the names of the columns, you can use the parameter which is names parameter and give the names to first column and second column and so on and so forth for rest of the columns if you have a more columns than these two columns. So header is equals to none, and the names parameter that you should remember in such cases where you need to give the different names or new names altogether to the header. So let's go ahead and execute this and see this thing in action. Now you can see that we have a trade and closing price as per the names that we have given. So names is the parameter that you need to use. Apart from that, you can also store the name of these columns in a different object altogether, like this. In this case, call underscore name, and then give the name of the columns like this. And using the names parameter, you can specify the call underscore name to basically give the name of the columns. So it will give the similar output like this. So if I'll just go ahead and use head and press shift enter, so with this the same output is given like there. The only changes, we have used the call underscore name object to store our name of the columns. Now the next piece is make the location variable. So here so far we have been giving the hard-coded location, but again if you want to use like this as an object, we have used it for the names. We can give the create an object of location LOC and give it a name over here, so that let's say this particular location is being used at 100 different times in your analysis, for example. So if you are not doing this, not storing the name of the location, you will have to go on those 100 statements and change it. But here in this case, if you are storing it in an object, you will just have to change this parameter at one single time, and all your 100 statements will be changed because they will be accessing this LOC like this, right? So that's the benefit if you are making your location variable. Otherwise you will have to go in 100 different steps and change the hard-coded value. So if I do that, it will again go ahead and execute this without any issue. So that's pretty much all I have for you in this video, and in the next video I will talk about the Excel data, how you can read it, and we will explore some options over there. Hi guys, welcome to the second video where I will show you how you will going to read the Excel data in Python. So if you have seen my first video where I have talked about how we can import the CSV data in Python, and we looked at a couple of options, and now we are moving ahead and we will see how we can read the Excel data into the Python and then do the further data analysis operation using Panda library or data visualization with the other libraries. Alright, so first piece is that as always you need to import Pandas library. So we are importing Pandas, and we are giving the alias name as PD so that we don't have to write Panda all the time when we are calling its function like pd.excel file. If we are not doing this, then we will have to write pandas.excel file. So that's the benefit of giving it an alias to the library. Alright, let's go ahead and execute this. I am pressing the shift enter, and after this we are using the function from this library Pandas, which is Excel file. This function is basically taking the path of the file, which is an XLS file, and if I'll just show you quickly the file that I have, and that is Superstore sample. Here it is, and here is the columns, the different columns that it has. So it's about the product information, some sales data that I'm using as an example. Alright, so after that we are reading that data and executing this. So let's go ahead and execute this. So if we are executing this, it will not give you the output like the direct data which you needed directly from the file. You need to basically parse it. That is a part of this object that we just created. So what we are doing is we are taking the file, creating an object orders, and we are saying that from this file object that we created, as it has all the sheets information and Excel file information, we want the orders sheet, because that sheet contains worksheet contains three different sheets, and one of the sheets is orders. So what we are saying that hey Excel file, we need to parse just the order sheets from this and then show us the first 5 observation. So that's a thing you need to remember. That's like a two-step process. First, get the entire workbook in the object Excel file, and then import the sheet using the parse function and give the name of the sheet. Alright, let's go ahead and execute this. Once we execute this, we see the first few observation. That is a useful function head, which gives first 5 observation, and here now the data is in front of us, that column. If you need any other sheet, you need to specify that sheet over here in the parse function. So that's one thing, one of the ways by which you can read the data. Another way to directly read the data is by using the read_Excel function. So this is also a part of the Pandas library, and the benefit of this function is that in just one statement you can get the output. So that file has the returns, the orders which have been returned, so that it has that sheet, and what we are saying that using the read_Excel function is go to this path, import this file, and take the second sheet. However, the parameter is 1, but as you know, the indexing basically start for the sheet objects is basically from the 0. So 0 is basically the first sheet, and 1 here indicates the second sheet. So that's why I have indicated 1. So if I go ahead and execute this, no issues, and if I go ahead and get the first few rows or the 5 rows, here I have the first 5 rows. So these are the two ways by which you can read the Excel data into the Python and do your data analysis. One is using the Excel file and then parsing what are all the sheets that I want. Sometimes it is really helpful because you just want to get entire information in one simple object and do that. Another one is just go ahead and within one statement just get that sheet and start doing the processing. So choice is up to you what you want to use, and get the data directly to the Python for data analysis. So that's pretty much all I have for you in this video, and I'll meet you in the new video with a new topic. Hi guys, welcome to the third video of this series, Pandas series, where I will show you how you can import the JSON data in Python. So JSON is a JavaScript object notation, which is kind of a data source or a data format which you can use as a cross-platform applications, and sometimes it has been given to you via some platform, where maybe web or some other location which is exporting you the data in a JSON format, and you need to get that data in the Python for doing the data analysis. So how you can do that, we will show it, we will see it here in couple of steps. Alright, first thing, as always, we need to import the Pandas library, and we will also need the inbuilt JSON library to do the JSON related operations. So I'll go ahead and execute this. After that, here is the sample JSON data, which has country information and its value. It has products column and its values. It has location column and its value, contact column, payment column and its values. Alright, so we will go ahead and execute this to create the sample data set. And once we create this, let's go ahead and load the JSON data in the format JSON underscore data, that the JSON data format that we just created. So the function is json.loads to load the JSON data, and we are storing this data in the company underscore data object. So let's go ahead and execute this, and now let's see the company data that we just imported. And here all that information is printed as it is. As you can see, contact, country, location, the payment information, and the products information. After that, let's see if you want to access any specific element. So for example, here in this case, payment, what you can do is using the print command, or simply by using the object company underscore data and specifying the its attribute payment, you can access the values of the payment. So it is helpful sometimes to get these values and to probably merge with some other data set or iterate through with some rows to perform some sort of an operation. So many times that way you need to access the specific elements of a specific object. So here let's go ahead and print that, and as you can see, it is giving us the values which is present in the payment column over here. Alright, now let's see how you can convert the values or the column into a data frame. So we can use the data frame object of the Pandas library and specify which column we want to make it as data frame, and we are storing the values into a new object called json underscore df. So let's go ahead and execute this, and now let's see this thing in action. So here we have created here we have the output in the format of a data frame, which is much more meaningful or in a readable format, which we are generally used to when we are looking at the Python output or a Pandas output. After this, let's see how we can convert a file into convert a data into a JSON data. So here we are creating one data set. So we are giving a name column and a value Bob, age, and its value is employed is true, boolean value, and we are using the json.dumps Bob to create the JSON data sets. That's the function that you need to use from the JSON library. So sometimes your end user or any other user who is also working on some other application may have the requirement where they just need the JSON data because that's how they have done the setting. So when you need to give the output, you may need to give the output into a JSON format, and that's where it will be useful to convert your data set into a JSON data. So using the json.dumps, you can dump the object in which the data is stored, and this bob underscore json will now have the JSON data. So let's go ahead and execute this. Okay, I need to execute this first. I think I have not executed that. And now execute this. And now let's see the JSON data. So here we have the JSON data as it is printed, which we have given it over here, but in a much more properly formatted way, which JSON probably another source which needs a JSON format will be able to access it. So that's pretty much all I have in this simple video, where if you're a beginner in JSON and looking for how to access the JSON data, you can follow this and get the data into your Python for data analysis. Hi there, welcome to the next video, where I will show you how you can load the HTML data in Python. So in this series, we have already seen the first 3 videos, where we have seen how we can load the CSV data in the first video. In the second video, we have seen how we can load the Excel data, and in the third video, we have seen how we can load the JSON data. And here on the fourth video, we will see how we can load the HTML tables into the Python. So HTML data is generally present in the websites, as you know, and many times they give you some meaningful information in a format of a table, and that probably you want to access and get it inside the Python for doing the data analysis. So first thing that you need to do that is importing or installing this libraries, which is HTML5lib. And to do that, you need to execute this command !pip install HTML5lib, and it will automatically gather the information which it requires to install the library and install it in your system. Since I have already installed it, I will not gonna do it again, but if you don't have this library, go ahead and execute this command. After that, as usual, we will import the Pandas library for doing any data analysis work, and from Pandas we will import the read_html as well, and we will also import the HTML5lib to read the HTML data and to do that processing which is required, the communication. Alright, so let's go ahead and execute this, and after that, here is a URL which is giving you the information about some mutual fund. And if I show you here, this is the same link, and here down here, this is basically the table which I am trying to import about the different mutual funds which are mentioned over here. So let's go ahead and execute this to store this URL into the URL object. So I'm pressing the shift enter, and after that I am basically using this read_html using this pd.io input output .html .read_html is basically the function, and I'm passing this parameter URL which is containing this URL, and this will have the table list that is present in this URL. So let's go ahead and execute this. It can take a couple of seconds based on how easy, quick or slow the internet connection is. And after that, let's see the table lists. So here it is showing you the information that it contains, and this information is not in a good format or a readable format. So what we can do is, usually this is the first table here, otherwise we could have seen some other information or some other table would be present, and we need to probably experiment this and see which table it is. So 0 is indicating the first table. That means get the first table from this object, which has basically contains all the information from this URL. So here we are accessing the first table and storing it into the mf_list, which is nothing but the mutual fund underscore list, and then we are basically seeing that list in the proper format. So let's go ahead and execute this piece. Now, as you can see, this list is coming over here properly, which one can read and then further perform the action. Now the exercise that I have for you is you need to search a little bit how you can take the first raw data like this and create a column from this data set. Alright, so how you can take these rows and put it over here in the column list. Well, if you're not aware, I think I have covered it in the CSV, while I have shown you how you can specify the column names and things like that. So go and watch that video if you have not already watched that, and you may require a little bit of searching and a little bit of work to basically remove this piece and put it over here. But I think that's like what's spending 30 minutes to see how you really need to massage the data in the real world to get things in a proper order. Alright, I'm leaving you with this exercise, and that's pretty much all I have for you in this video. Hi guys, welcome to the fifth video of this series, where we are talking about how we can do the data analysis within Pandas, and we have started with importing the different types of files. And now we are taking here the second step, where we will look at some of the basics of data series or some of the basics of data analysis, to be precise, where we are first looking at series. And here we will look at some, first of all, fabricated series, and then we will look at the actual data frame, and from where how we can get the series to do the data manipulation or access the specific type of objects for any data analysis work. So for that, first of all, we need to import pandas as PD, like as always we have done in the past 4 videos, and from pandas we need to import the series as well to work in this video. Alright, let's go ahead and execute this. So series is nothing but a collection of similar values like this, or there may be a scenario where it may have the mixed collection as well, but generally you will find that it will have the similar values like this. Here in this case numeric, and down there okay, this is index, but it can also have the text values. Alright, let's go ahead and execute this, and let's see the series. So that's how the series can be seen as an output, and with the series it has this numbering attached to it, and what it is nothing but the index, which is created by default. So index is also very useful. I will cover this piece in a separate video, but idea is that each value in a series is attached to an index, so that you can either access the index and get the value, or you can directly access the value. If you want to see the index values of any series, you can use this method, which is index, ser.index. So ser is nothing but the series. So let's go ahead and execute this. So it is, as it is saying, it is starting at 0, stopping at 6, and step is 1. So 0 to 5 is basically the 6 values that it has, and that's what it is showing it over here. Alright, let's go ahead and try to access the values with the help of index. So now that's like the operation you would normally do in any data analysis work about accessing any series value or accessing any data frame value to basically look at a certain data point. Alright, go ahead and execute this piece. So ser0 is nothing but it contains the value 5, and that's what the output is. Similarly, ser3 is having the 20 as an output. So that's basically an example of how you can access the index and get the output as the value that it contains. Alright, apart from this default index, here what I have done is, by using the index parameter of this series function, I have created a different index, which is nothing but the name of the characters. So just to give you an example, that apart from the default one, you can also have this particular piece where you can specify your own custom values for index. Alright, let's go ahead and execute this, and now see this thing in action. Here we have the index. Earlier it was numeric because we did not specify anything, but here we specifically mentioned that this is the index we want. And now if we want like this, we can access the values by A, B, C, D, and E. This is really helpful where your index is having any business specific names which you would really like to give to your values while accessing it. Alright, so let's go ahead and see one example of what you will get as a D over here, which I have just mentioned to access the value data point. And as you would have predicted it correctly, it is giving you the output 20 over here. Next thing I want to show you is series from our data frame. So in the previous video, one of the previous videos, we have seen how you can get the Excel file into the Python for data analysis. So let's go ahead and execute this piece, and showing its first 5 observations with the help of the head command. And here are these observations, and we'll try to get the series from it by accessing a specific column. Alright, so series from a data frame, and here is the order priority. That's it, that's the series. I want to get it out. So order priority is nothing but this column, and low, high, high, all of these different values that it contains. So if I go ahead and execute this, here is the series that it has created. 0, 1. So this is the index and this is the values. Okay, next piece I have for you is which is another way of accessing the data series by using the dot notation. Here I am using orders dot profit, but if you have seen the previous command, I have used the brackets. Why I have used brackets here? Because this column name has a space between the two words. That's the reason. So that's another way by which you can access it. So if I go ahead and execute this, it will show you the series. Alright, if I go down and show you the next command. Here what I'm doing is adding the two numeric series. So orders.profit and order.sales. So let's see what will happen. It will give you the addition based on the values that is contained in orders and sales. That's way you can perform the arithmetic operations also on two different series. Another way by which you can do the addition on the text data is by giving their name and specifying the space using the plus sign and saying that you want to concatenate these two string or add these two string. If I go ahead and execute this, you can see low, regular. Low is basically the order priority and regular air is basically the shipping mode. Similarly, high, delivery truck, high, regular air. So if you want to concatenate two different strings, that's another way. That's a way by which you can do it. Now let's see some other examples that I have it here for you. If you want how many values a series contains, so here we are accessing order.sales, which is a series, and we are using the property called size to get the size of this series. If I go ahead and execute this, it contains 8399 values. Alright, if you want to get the array-like output for further processing of data, let's say by using the numpy array and all of those some machine learning stuff, we can use the values property from order.sales to get the array-like output. So if I go ahead and execute this, you will get an array which you can further use it. And once you will further advance your learning into the machine learning and all, you will see that this particular property is really helpful to get the data in the array output kind of a format. So that's pretty much all I have for you in this video, and I will meet you in the new video, the new topic. Hi there, welcome to the 6th video of this series working with data frames. And here we will look at some of the ways by which we can work with the data frames in a general way, which is required in pretty much every data analysis. Alright, so let's go ahead and import the Pandas library, and from Pandas import the data frame as well. So let's go ahead and execute that, and we will going to read the Excel file which we have read in the previous videos as well. Here I have shown you how to read the data from an Excel file, and we are reading the sample superstore file, and we are getting the first sheet by accessing by specifying this 0, which indicates the first sheet, 1 will indicate 2, second sheet, and so on and so forth. So first sheet name is orders, so that's what the object name I have given to store the values. So if I go ahead and execute this, and using the head command or the head function, I will simply get the first 5 rows if I want to have a look at the data, which I usually want after I have read the data. So here is the data set that I have just read, and here is the columns information. So this will give me an idea about for some verification that all my data points, like number of columns and their values, are properly coming or not. Well, if you want a little bit less or more information, you can always specify a value over here. So if I want just 2 values, I can go ahead and say 2, and I will only get the first and second observation. If I want more, I can specify, let's say 20, and get more values. Alright, after this, let's get the column names that are present in this data set, and it's pretty easy. As you can see, I will just access this order object I created and use the columns to get the list of columns. Alright, here it is, the columns information, all the columns that it has. Now the question arises, why I would like to do that? Well, in many cases, after loading this entire data, you may want to create some subsets of data set. So for example, only some specific columns you may want to use, and instead of writing each and every column name, it's pretty easy to get all the column names in a format like this and specify in the subset, which I will show you in next couple of commands. In that way, you will going to create a subset of a data set which is very specific for your analysis, and for that reason you may want to access the columns information. Alright, here we are creating a subset which I just mentioned. So what we are doing is we are using the data frame functions, specifying the first values as the orders that we want to access the orders data frame that we just created, and these are the only columns which I want from this orders data frame. And with the help of this data frame, we are creating a new data frame which is orders underscore subset. So this is pretty generic, but you can give any specific name which is related to your analysis. So I have just taken copied and pasted some columns, like just picking up like this and pasted over here, and I'm just executing this. And after that, I'm using the head, and let's just show the first 3 observations. I'll specify 3, execute this. So this way, now it's pretty easy for me to look at this data set, because it contains only those columns on which I want to do the analysis, but not the entire hundreds of columns. Let's say if that's the case in your data set. So that's why it is really helpful to access the columns and then create a data set with the help of this data frame function. Now let's see what happens in case if you are giving any additional column which is not present in your data frame. And here I have specified the returns after the customer name. So let's see this piece in action and see what values it contains. So I'm pressing execute this, and it is just containing the NaN. So sometimes it is useful to create additional columns, and that's the way you can create it. And maybe later in the stage you have a plan to store some calculated value. Let's say you get the order number from a different file, and you want to assign the order numbers over here with the help of some criteria. Or let's say you are having a final price, for example, and you are saying sales plus profit, and then finally saying, okay, this is my final price on which I have got the revenue. So that kind of operations you can create by creating a new column, and that's how you can specify the new column, and after that you can specify the calculation, which we will see in subsequent videos about how we can do that. And after that we will see how we can get the individual columns, like we have seen in the previous videos about how to work with the series. So if I go ahead and execute this, this is the way I can get any individual column values for, let's say, if I want to do some operation on a particular column values. Alright, after that what we can do is or what I have is how you can access the series with the help of the dot notation. And if you have seen my previous video where I have talked about series, so this dot notation is helpful only in those cases where you don't have any space between the column names. So for example, this order date is basically having a space between these two words, and that's why I cannot use the dot notation. But here down there in this case, in case of sales, I don't have any two words which are having space, so I can go ahead and use this and get the sales values. Alright, and after this I have the last command for you, which is removing the column. Alright, if I just scroll it down, so first thing is deleting the column. So if I just do this, so this was the additional column that we added, and let's say we want to remove this. So if I go ahead and execute this, and along with that I am executing the head command. Alright, as you can see, with the help of del delete, I have removed the returns column, and with the help of head I am able to see the first 5 observations, and in that I can verify that this column is not present. So that's the way you can do the operations with your data frame and get it in the desired way or that is required for your analysis. Hi guys, welcome to the 7th video of this series, where I will talk about how you can delete the rows and column from a data frame. So let's go ahead and start it by importing the Pandas libraries like we have done in all the videos. So go ahead and execute by pressing Shift Enter. Once we have imported, I am reading the Excel file that I have read in the previous videos as well, so nothing new, and I am reading the first sheet, which is orders. So if I go ahead and execute this, it will read the file. It will take a couple of seconds, so it's executed, and now I need to see some first few observation. I can use the head method to view the first 5 observation. So I'm pressing Ctrl Enter, and it will show me the first 5 observation to verify whether I have properly loaded the data into the Python or not. Alright, after that I have orders which I have created just now by accessing the Excel file, and let's say I want to remove this first column, which is row ID. So if I show you that, here is the row ID that I have, and let's say I need to remove this column. So what I simply use is the drop function. If I need to say orders, say from orders I need to drop, so orders dot drop, and specify which column you want to drop and after that the axis. So axis is equals to 1 is indicating that you want to drop the column. If it is 0, that means it's the row. So whenever you need to drop the column, always have the axis equals to 1, and in place is equals to true is indicating to make the impact in the orders column. If this is false or you are not specifying this, the column will be this command will be executed, but the change will not be impacted into the original data frame, which is orders. So that's why you need to have the in place is equals to true. And then I'm saying orders.head2 to see the impact in the first two observation. So I'm executing this, and now you can see order ID is the first column and the row ID have been removed. Alright, let's move ahead. Now in this example we have seen only the row ID, the one column. Let's say I need to remove the two different columns. What I can use is the bracket to indicate the two column, order date, order priority, order date and order priority. X is equals to 1, similar to the previous one, and in place is equals to true to make the impact happen into the orders data frame. So execute that and see this in action. Alright, now we have order ID, and after that those two columns have been removed, the order date and order priority, and after that we have order quantity. Now let's see how we can remove the rows as well very quickly by specifying the axis is equals to 0. So now what we want is we want to drop the second and third row, and we are specifying the axis equals to 0 and in place equals to true, and saying viewing this in action by using the head function. Head basically shows the first 5 observation. So let's go ahead and execute this and see this thing in action. So as you can see, after 0 and 1, the second and third index values have been removed. So that's the important point, that these values indicate the index values. So whenever you are specifying, that index value will be removed. So that second and third is removed. So after 0 and 1, you are seeing the fourth. So these are the different ways by which you can remove the column or remove the rows and get the desired output from your data frame. And that's pretty much all I have for you in this video. Hi there, welcome to the 8th video of this series, where I will show you how you can apply the filters on a data frame to filter the data and get the specific values which you need for the analysis. As always, we will start with importing the Pandas library by giving the alias name as PD, and I'm pressing the Control Enter to execute the command. After that, we will going to read the Excel file which I have been using in my examples, and we will read the order sheet by indicating that we want to access the first sheet by indicating 0 and give it a name as orders. So with the help of pd.read_excel, I can read the Excel data. So I'll go ahead and execute this. It may take a couple of seconds based on how big or small the data set is, or if it is your processor is busy or not. Alright, let's go ahead and see the first two observations by using the head function, which I have been using so far in previous videos. And if I execute that, as you can see, I have the observations here. So that's good. And now let's go ahead and see some filtering in action. So first thing is, let's say if we want to get the sales values which are above 500. So here is the sales column. So I don't want 261 and all of those things, but I want to perform my analysis only on those values which are either 500 or more than that. Then I can indicate using the orders. This is the object that we created earlier, and saying within the bracket notation, order.sales is greater than or equal to 500, and press Control Enter to execute this, and it will give you all the values which are above 500. As you can see, 10,000, 4,900, 905, all of those values, if you will see, it will be more than equal to or more than 500. Alright, now let's see how we can filter the text data. So same order within the bracket notation, Again, you need to specify order and get the column name in the bracket notation, because this is having the space. That's the reason you need to get this piece in bracket. Otherwise you could have accessed it like with the dot notation with the orders. Alright, and then specify that you don't want any of those orders which are indicated as high, like this in this case, and just the low or medium or not specified. So let's go ahead and execute that, and now you will see no high order priority. Alright, so that's good. Now let's make it a little bit more complex. Filtering with the multiple criteria. Now what we want is, we don't want order priority high, as well as we want only small business. So with the help of AND operator, and this indicates that both the conditions should match, and then only you will get the data. So in this case you will get only small business data where category is order priority is not equal to high. That means only the low, medium or not specified. So another important thing is making sure that you have the small bracket with each condition. Otherwise this statement will give you an error because you are specifying multiple condition with the help of either AND or OR operator. I will show you the OR operator in next command, and there is a requirement that these conditions should be covered with the help of this small bracket to have the evaluation in place. Alright, so now let's go ahead and see this piece in action. If I go ahead and execute this, this is now executed, and if you see, I will have the customer segment only as a small business, and the order priority will not be high. That means only low, not specified at all. And if you will see down there, there will be reduction in number of rows. So here it has 1283 rows, whereas if you will see over here, the rows will be much more than that, 6631. So that's the impact of AND operator. After that I have the OR operator. In case of OR operator, only one condition will have to match, evaluated or match. If first condition is met, then it will not go to the second condition, or if first condition is not met, then it will go to the second condition for the evaluation. So in this case, the output that you should expect is only for the order priority which is not equal to high will be evaluated, and it will not go to this second piece. So in that way you will have all the business categories. Alright, let's go ahead and execute that. And if I go down over here, as I mentioned that you will have all the business categories, because that's the case with the OR operator. At any one condition, either first, second, or if there is any third or fourth condition, should match, and that is equivalent to here in this case is only with that much statement was sufficient. But sometimes you would have the requirement where you want to iterate through multiple conditions, because there may be a scenario where not just one condition is present but multiple conditions are present, and you want to satisfy those conditions with the help of OR operator. Alright, let's go ahead and see a couple of other OR that I have here. And the next thing is the similar one. You can go ahead and execute this, where we are simply saying that order priority equals to low and order priority is not equal to high. But this is useful because
we are saying with the help of AND operator that we want orders which are not equal to high and not equal to low. That means only the medium and not specified. So let's go ahead and execute this. Alright, now you will see only the not specified and medium, because in case of AND, both the condition will be evaluated and then you will get the output. In case of OR, only one condition will be evaluated. If first condition is not met, then it will go to the second condition. But if first condition is met, then it will not go to the second condition. That's the difference. Here we have is in, which is a shortened way of using the OR condition like this. So let's say you have 10 different OR conditions that you want to evaluate. Well, instead of writing these 10 different conditions, what you can do is you can use the is_in method. So same syntax within the orders, will specify the column name. So here in this ship mode, and we are saying that we only want ship code which are regular air or delivery truck. So if there are any other values which you want, you can get it over here. So this is a shortened way, and if I go and execute this, you will see the categories like regular air and delivery truck. So as you can see, this command is really helpful. Let's say you have 15 or 25 different categories, and instead of writing all that, you will just specify it in the values over here and you will get the output, or you will get the data set as per the required output. So these are all the different ways by which you can filter your data frame, and there are many other complex scenarios in which you would like to format or you would like to filter your data, which are not covered here, but these are mostly very generic or generally used operations that you will find in any data analysis operation to get the required data output in your case. So that's pretty much all, and I'll meet you in the new video with a new topic. Hi there, welcome to the 9th video of this series, and here we will talk about the sorting values in the Python data frame. Right, so as usual, let's go ahead and import the Pandas library by pressing the Shift Enter or Control Enter, whichever you like. And now let's read the Excel file and show the first two observations. So Control Enter to execute this. I have been using it from past couple of videos, so I think you are pretty much used to of it. I'm not explaining the entire functionality, what it is doing. Alright, here are the columns. So it has successfully imported the data. Now let's sorting the ascending in ascending order. So what we are doing is taking this particular column and sorting the values of this column. Alright, so here is the column that we have, sales dot sort values, and as you can see, its values have been sorted in the ascending order. Alright, now let's see some other example in action. If I go down quickly and see some piece in action. Alright, so here we have again the sales and sort values, and now we are sorting in the descending order. That means the biggest values first and lowest values in the end. So what we need to do is specify the ascending is equals to false. If by default it is true, but if we need a descending order, then we need to specify ascending is equals to false. And to get the top 5 values or the first 5 values, we need to use the head as I have shown you or I have explained you in my previous videos as well, give you the first 5 observations, and you can specify any number like 10 or 15 to get the desired number of rows from your data frame. So I'll just go ahead and get the 5 rows. Alright, here I should get the first 5 rows. 1, 2, 3, 4, 5. That means the top 5 sales values from my sales column. Okay, and now let's sort those columns that has space. That means columns like order date. Since those columns which don't have space in their words, they use the dot notation, but in case of such columns we need to use this bracket notation, and within the bracket we need to specify the column name and then sort values and head just to indicate the first 5 values. So if I go ahead and execute this, it will give you the first 5 order dates to you. Alright, next thing is basically sorting the entire data frame. So far we have seen only the column values, but let's say we want to sort the values by sales and we want entire data frame to have that impact. So to do that, you need to say orders, then dot, not the column name, but directly specify sort underscore values, and then specify the column name sales into it to make that impact. Earlier, if you remember, over here we have said orders.sales.sort value. That means impact was only on sales, but here sort value is attached to this orders, so that's why the impact is on the entire data frame, and here we are specifying with which column we want to make an impact. So with the sales column we want to impact. So let's go ahead and execute that. Here now we have the sorted data frame. As you can see, 2.24, 3.20, and all the other observations have been sorted accordingly. Now let's see how we can sort in descending format or descending order. So if I go down, and here I should have my command sales ascending is equals to false. If you remember from the previous command, this will give us the descending order. So if I go ahead and execute this, now it should have the biggest values first and sorted accordingly. So as you can see, 89,000, 45,000, 41,000, so on and so forth. So now my data set is sorted as per the descending order. After that, I have an example how you can use the multiple values and then sort it in the required format, whether ascending or descending. So here descending is equals to false. That means we want, ascending is equals to false. That means we want descending order. Alright, so main idea is that this is the way, using the bracket notation, you can give multiple columns based on which you want to sort the entire data frame. So let's go ahead and execute this. And now our data set will be sorted as per these two columns, sales and discount. So that's pretty much all I have for you in this video about how you can sort any single column, or with the help of a single column, the entire data set, ascending or descending order, all of those things, and get the output in the required format. Hi there, welcome to the 10th video of this series, and in this video I will show you how you can describe a data set. So describing is nothing but generating the statistics from a data set based on its column that it contains. So a data set contains a lot of numeric columns and as well as columns that contains character data. So numeric column has a lot of statistics like min, max, standard deviation and all, but the values, the character values only has one meaningful property, which is count. So let's see this thing in action, how we can perform these kind of operations, generating statistics with the help of the describe method of Pandas. Alright, so as usual, we will start with the importing the libraries Pandas. So I'm pressing Ctrl Enter to import this. Then we are reading the Excel file that we have been using and showing the first two rows of this data set. And it may take a couple of seconds based on how small or big your data set is. Alright, here we have the values. So it has properly imported the data. Now with the describe method, by default it takes only numeric column. So if I go ahead and execute this, you will see that only numeric column that it has taken, along with row ID and order ID, even though it does not have a lot of significance, but it has taken that columns, seeing that it contains numeric values, and give us other numeric columns like order quantity, sales, discount, profit, unit price, and their related statistics like count, mean, which is nothing but average, standard deviation, minimum, values within 25th percentile, 50th percentile, 75th, and the maximum. So these are the some quick summaries which every statisticians would really like to see. As the first thing they would like to do, start with the analysis. So that's where the describe is really helpful. Let's say you want to include the the character data as well. So you need to use the parameter within the describe, which is include is equals to all. So let's go ahead and execute this. And now you will see all the columns have been included, like order date and order priority and things like that. So along with the count, as I mentioned, there is another one which I did not mention, was unique, how many unique value it contains. So that's also a very good one. Similarly, it has another one which is frequency. So that's why this describe is really useful, because it will give you all these statistics pretty much handy, and you can get some important inferences out of it. After that, let's see if we want to only include the character data. So we can specify include is equals to object within these brackets. So these brackets are important. If you are not giving them, it will throw you an error. Alright, let's go ahead and execute this by pressing Ctrl Enter. And here you will see only the columns which contains character data. Alright, after that, if there are any specific multiple types of formats available for your data frame and you want only specific types, you can say include is equals to apart from object. After a comma, specify that you want float, that means the numeric one as well. So go ahead and execute this, and it will include the character and float values columns. Alright, so that's straightforward but very useful when you are starting the data analysis piece. After that, how we can describe a specific type of values by filtering it. So for example, earlier in the videos we have seen how we can filter the data, and here we are just interested only on those orders which are of high priority. If you want to see that the statistics related to it, I can just go ahead and execute this. Now this statistics is reduced to only orders which are related to high priority, and that's what the things becomes more and more complex in the real time, because you want to pinpoint to a problem by going more and more specific into the question to get the answer, more and more specific into the data to be precise. And after that, just extending the complexity by introducing AND to make sure that we are looking at only those orders which are of order priority high and their value is more than 10,000. The sales value is more than or equal to $10,000, and we want to get that statistics. So just an example of how things can go complex. So if I execute this, you will see that earlier the count was 1768, but now the count is 68. That means that's how you have reduced the data to further do the specific research to get the answer of your question from the data. So that's how you can use the describe method and get into the data set and get the summary statistics out of it. And that's pretty much all I have for you in this video. I'll meet you in the new video with a new topic. Hi there. In this video, I will talk about the string operations with Python Pandas series. So string operations are one of the very common operations where you have to manipulate the strings to get it in the desired format. Things like making them in uppercase, lowercase, replacing the string or replacing it with some specific value that you want, or maybe joining the strings. So I will show you how you can do it in the Python Pandas series with the help of Pandas library. So for that, first of all, let's go ahead and import Pandas library as PD and then get the file. So the file that I have is the Superstore sales as an example file which I have been using from past so many videos, and I am getting the first sheet. So 0 is indicating that I am getting the first sheet from this Excel file, and this is the function pd.read_Excel that you need to use to read any Excel file, and I'm storing the first sheet information in this object called orders. So let's go ahead and execute this by pressing Shift Enter. Alright, so the file, I have it now in this object. Now let me show you first couple of observations. So let's say I want 3. By default it shows 5, so I can specify any number within the head and get the first 3 observations. And here I have the information about the different columns and along with the data values that it has. So let's say we want to know how many unique value that let's say order priority has, or maybe province, or maybe customer name based on the values that this sheet contains. So for that, what we can do is we can get orders, first of all, that object, and then maybe order priority, and then just specify unique. With this, it will give you all the unique values that are present in this particular series. So right now, by this method or by writing this statement, we are accessing order priority series and we are asking the unique values. So for that, let's press Shift Enter, and here we have low, high, not specified, medium, critical as the unique value present in this series. You can also get the number of unique values. So sometimes along with the unique values, you are interested in getting the number. Say for example, you have millions of rows of data set and you have a customer name or maybe product name. So you want to know how many products, unique products that you have in that data set. So for that, what you can do is, again, you can write orders, order priority, and the function is, or the method is, an unique, UNIQUE, unique. Alright, with this, it gives you the value 5, 1, 2, 3, 4, and 5. Correct. So that's how you can get the unique values as well as number of unique values present in the series. This way you can access any other series by giving its name. So for example, if you are interested in knowing the customer name, the unique customer, because one customer, for example Barry French, is coming couple of times, like Barry French, and you are interested in knowing how many unique customers that you have, then you can simply pass on the value over here to get the unique names, or if you want unique count, you can get the unique count with the help of an unique function. Now let's go ahead and explore a couple of other options. So for example, this is in a title case like this, not N is capital and S is capital. Let's say our requirement is to convert this entire string into uppercase. So for that you can again write orders, order priority, and then you need to write str, which is a library, and then you need to write upper. This way you will get whatever values this series contains will be converted into the upper values and give you the output. So let's go ahead and execute this. So once you execute this, you will get all the values as the output. Now the important thing to understand is when you are doing this operation, there is no impact into the data set, because if you will see, for example, if I just comment it out and show you orders and order priority, let's say first couple of observations, you can see it's still in a title case because we have not made any impact into the data set but a temporary impact to the series. If you want a permanent impact, then what you can do is you need to store this operation. Say for example, I just copied, and instead of writing, I will simply copy this and paste it over here and say this is how I want to store the values. So this way my operation of conversion will store into this order priority series and it will be a permanent impact. So for now I'm good. I just wanted to explain you so that you are not confused why it is not impacting your data frame or the data or the sheet that you imported. After that, like upper, you have lower, and that will, and I will just use head so that it is not showing us all the values, and if I press enter, all the values are converted into lowercase. Similarly, you have title to convert it into a title case where N will be in capital and S will be in capital and rest other characters will be in the small letters. So let's go ahead and execute that. And as you can see, the first letter is in capital, and in case there are multiple words, so the first word or the first letter of the word is capital and the second letter of the second word here in this second letter here in this word is capital. Alright, let's move ahead. Let's say you are interested in knowing the number of characters each of these string contains. So if that is the case, you can use the len method, the length method, order priority priority dot str dot len dot head. So this way you will get the character count or the word count for each of the word in this series. And again, you can create a new column, for example like this, orders order priority len is equals to this, and this way you can store the values into a separate column altogether and do your data analysis. So sometimes when you are doing the text analytics, this function can become really helpful because different types of length of a word or of a sentence will help you understand or do the categorization of the data. So sometimes that's where you will find it pretty helpful. Alright, let's move ahead. So earlier we have seen that a particular series is in title case or upper or lower. Let's say you want to figure it out from your series whether it is in a title case or not. So that's kind of a Boolean operation that you want to do. So how you can check that? So you can first of all write the series name and then str and then is title and then head. So this function is basically helping you understand whether this series is in title case or not. So if it is not, a particular word is not in a title case, it will say false, otherwise it will say true. So let's go ahead and execute that. So in this case, all of those values are in title. But let's say we change it a little bit. So I'll just copy this so that I don't have to write it again. I'll copy this and paste it over here and say upper. Right, and store the values in the data frame. I'll just copy all the series of data frame, and now we are saying whether it is a title case or not. So let's go ahead and execute that, and now you can see they are all false because we have made it into an uppercase, whereas after that we are checking whether it's a title case or not. If we will change it from is title to, let's say, is upper or is lower, then it will give you the true value. So now it has been changed to true. So this way you can check whenever you are performing string operations whether something is in some word in uppercase or a lowercase, or they perform the series operation entirely to check whether it's in uppercase, lowercase, or title case. Next, let's check whether the series contains a particular word or not. So for example, this order priority, I will just copy it up till here and paste it and say contains, and let's say word not specified, and I will just select first few observations. So this will basically give us again true and false, whether the particular word in a series will contain the not specified or not. Wherever the not specified will be there, it will be true, otherwise it will be false. So let's go ahead and execute that. So not specified, for everything it is saying false because we have changed it into an uppercase. So we now need to say in entirely capital SPECI specified, and now you can see it has changed to true because that's the operations we performed over here. And now with contains you can get the true value. So this way you can identify whether a particular word that series contains is present or not, and this way you can even filter the series, and I'll show you in subsequent videos about how you can really use it to filter out the data. Alright, let's move ahead and see the replace method. So sometimes say for example in not specified you want to change it to maybe an A or a null value because you don't really want to count these specific strings. So how you can do that? Again, we need to write it until here at least, because there's a string operation and we need to use the str and say replace replace not specified with NA. Yeah, let's go ahead with capital NA. Alright, and let's pick it ahead. So as you can see, low, high, and now not specified is not coming, but NA is coming. So there are a lot of operations that can be performed with the help of these string methods, and you can look at basically the library, str library. So you can write pandas str library. And here you will find the str package or the str library. Let's quickly see our search again, and here you go. Alright, so here you have the str and contains and other things, but down there you will find that string handling, and here are all the different kinds of methods that is present for the string handling. So we saw contains, there is a count method, it's capitalized method, len method we saw. So a lot of methods are here, and you can visit just simply writing in a Google search and see whether the particular function for which you are really looking for is present over here or not. So that's pretty much all I have, and I'll meet you in the new video, the new topic. Hi guys, in this video I will show you how you can group data using the group by clause. So let's see this thing in example by first of all importing the pandas library. Import pandas as pd, and then our data set which we are using from past couple of videos, the superstore sales, and we are getting the order sheet by specifying first sheet information. And let's look at a couple of observations. So to do the group by, or first of all, why we group by? So group by is really helpful in seeing the thing in context. So for example, let's say we want to understand by order priority the sales. Under high priority, what is the sales amount, or what is the average sales amount, or the maximum or the minimum sale. Similarly, if you are interested by looking at how many sales or profit or the discount is happening via different shipping mode, or maybe the province and the region. So you have a lot of columns on which you can really do the group by and see the things in context based on your requirement, like sales or discount or profit. Alright, so first of all, what we need to do, we need to specify the group by clause. So to do that, orders dot group by, and then the name of the column. So we'll experiment with order priority, 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 and then we will first write the column name, the measure column name. So order is basically the dimension or the categorical field on which we want to group by, and the measure. So let's say sales. And then we need to specify the aggregation operation, because group by basically aggregate the values based on the dimension value that you are specifying. So we need to aggregate the sales amount, and let's go ahead and use simple sum and enter. So here we have the sales values by critical high. Since they are pretty large value, that's why they have been specified in a scientific notation. But let's say we want mean, for example. So again, let's copy that till here and do this sales dot mean, which will give you the average sales under each category. Probably somebody asks you the highest sale in the category. So again, you will go ahead and get until here orders dot group by order priority, and I'll just scroll a little bit down. Yeah, order dot group by order priority, and then say max. So by specifying this max, you will get the maximum sales under each of the category. So let's go ahead, and these are the maximum sales amount, individual sales amount under the categories, order priority categories. Similarly, if you need the minimum sales amount, then you can specify min as well, my n, control enter, and this is the minimum sales amount that has happened in that category. So far we have seen the different min, max, average or sum for these group by and group by categories for this data frame orders. Let's say you are interested in seeing all of these things in just one single matrix. So how you can do that? Well, for that let me a little bit scroll and say orders dot group by, same expression, order priority, and then sales dot agg. This is the function that you need to use, and within that you need to use bracket and say sum, mean, max, and min. So this way aggregate function, agg function, comes really handy, because you can then create a proper metric that you can use it in your presentation or as part of your report, and use or show the things in a much more meaningful way. So let's go ahead and press enter, and here we are with the sum, mean, max and minimum for each of the categories that are present. Let's say you are interested not grouping by not only order priority but maybe shipping mode as well. So what you can do is, I will maybe just copy this entire piece, paste it over here, and here in the group by I will open up this bracket and hand it over here, put a comma and say ship mode, which is one of the column in this data frame, and press enter. So now we are here with this metric where we have order priority, shipping mode, and there sum, mean, max and mean. Mean is nothing but the average. And this way you can make your metrics little bit complex and meaningful for your analysis or report or your presentation. One last thing I will just show you, which will grouping all the columns that are available. So orders dot group by, and let's say order priority, and press enter. Yeah, so one thing that we need to specify is whether we want average or what do we want. So I will just cut this, and that's why it has not shown us the output but just created the object. And let's say we want mean, and now you can see wherever it has identified the numeric column, it has given the average. So for order quantity, sales, discount, profit, wherever it identified the numeric column and gave you the values by order priority. So this way you don't have to specify the column, the numeric column on which you want mean, max or sum, but simply specify the group by column and what you want as a aggregated operation, and you will get all the columns as an aggregated value for these categories. So that's pretty much all I have for you in this video, and I will meet you in the new video with a new topic. Hey guys, in this video I will show you how you can answer some of the business question with the help of Python Pandas data analysis. So far we have seen a lot of functions like group by or some string operations and things like that, and we will just combine all of those pieces here and try to frame a business question and answer it. So to do that, first of all, import the Pandas libraries, spd, and import the dataset. So here is our dataset, and we are just reading the Excel file that we have been using so far, and let's simultaneously get some 2 rows maybe. Alright, here we have the 2 rows, and let's say we want to identify so we have a couple of other categories like customer segment, and our business is interested in seeing that where the highest sales are happening. So to do that, to answer that question, what we can do is we can write orders dot group by and group by customer segment, and we say sales dot sum. Press Ctrl Enter, and we can easily answer that. First of all, it is corporate segment, then it is home office, then consumer, and then small business. They may say, okay, this is fine, but where is the most profitable area or the customer segment? Well, you can again copy this, simply paste it and change from sales to profit, as profit is one of the column we have in the data frame, and again press enter, and you can see that corporate is the highest profitable one, followed by home office, then the small business, and then the consumer, which is little different when it comes to sales, because in case of consumer it is the 3rd highest one by sales, but it is the last one when it comes to the profit. Alright, so one other thing is, instead of customer segment, let's say you want to see the profit by some other category, then let's change that category to maybe for example product category. Let's say your product team is interested in seeing which product category is really profitable one. So technology, followed by office supplies, then furniture. Let's say you are interested in seeing that when an order has been placed, how many types of particular product has been appeared in the products and the orders. So for that, what you can do is you can say orders, and there is a field name product name, and to know how many times that name has been appeared in the orders. So basically it gives you an idea whether the product is popular or not. So you can use value underscore counts. So value counts give you this information. So for example, global high risk has been appeared maximum time 24, followed by Fiscus, box office, master giant. All of these three have been appeared at least 22 times. So this way you can get this entire list about how many times they have been appeared, followed by those items which have been appeared very less. And this is really helpful to understand for which product orders are coming more and for which products orders are coming less. Similarly, if you are interested in knowing how many unique products that you have, then you can write product name dot n unique, and it will show you that in your company you have total 1263 unique products. And now I want to show you one of the common operation in every analysis you require, identifying the top 3, top 5 or top 10 product names by either sales or profit. So how we can identify is by using the group by, orders dot group by, and by which we want to group by, let's say product name, and then by profit we want to see, and then we want sum, and then use the function n largest, and specify, let's say we want top 5 products, and press enter. And here you have your top 5 products that you may want to include in your analysis. Similarly, if you have a requirement that Control C, you have a requirement where you want the lowest one, then instead of n largest, n smallest, and press Control enter. So these are the ones. So these are pretty interesting because these are in negative. That means some orders have been come back for these particular products, and it will be pretty interesting to see why and go deep down into it. So this is about how you can use the various functions which are present in Pandas to reach to some sort of a conclusion or a little deep down into your analysis and give a all-round report or presentation to your management. So that's all I have for you in this video, and I will meet you in the new video, the new topic. Hi there, in this video I will show you how you can change the rows and columns display options in Python. So many times when we import the data, we are limited by the number of rows and columns that Python data frame shows. So let's see how you can adjust it so that if you want more rows or columns, or all the rows and all the columns, then how you can display it. So first of all, let's go ahead and import pandas as PD, and then go ahead and implement or import the data. So this is the data we have been using, and I'm going ahead and showing this data only, and what I'll do is I'll just show the entire data set by just placing the object. So this is what I am importing it over here from this Excel file, and 0 indicates that I am importing the very first sheet, which is order. So that's why I'm creating this object orders. Alright, let's go ahead and execute that. It will take a couple of seconds, but yeah, it's pretty fast, as you can see. And now if you see these number of columns, so we have all these columns, but down there you have these 3 dots or ellipses which indicates that it has suppressed some of the columns based on the settings, the default settings that it has, and then it has shown some further column, not all the columns. Similarly, if we see the rows, I'll show you going slowly, and that you will see that many rows have been suppressed. So if I go down, yeah, so from 29, see this, these rows have been suppressed, and then you have 8369, 8370, and then so it appears to me that it shows maybe around first 30 and last 30 rows, but total, as you can see that it has 8399 rows and 21 columns. All right, so let's see how you can adjust the settings. So for that, you have the method called pd.get_option, and within that you need to specify display.max_rows. And if I execute this, it is giving me an error, and let's see this, why it has given. I think I have specified it correctly. So it is giving us display.max_rows. Well, it is saying that there is no such case. Let's see whether I have specified it correctly or not. So what we can do is, to know all of these different options, we have one of the method called pd. So pd indicates pandas.describe_options. So let's go ahead and get this option and see why it is giving us an error. Describe_option, and execute this. And here we have all the display related options. So let's go down and try to see the option that we were trying to execute. So it has display.height, what should be the height, large error, latex, all of these, line width, what should be the line width, maximum categories, this sets the maximum number of categories Panda should output when printing out a categorical. So a lot of useful information. And the property I was trying is, one of the property I wanted to show you is max column, and another property I wanted to show you is max_rows. Yeah, so this is the property I wanted to show you. So, but it said it's a wrong option, so I'll just copy it directly from here and put it over there. So it's saying that if max_rows is exceeded, switch to truncate view. That's the default property. Depending on the large underscore object are either centrally truncated or printed as a summary. Alright. And the value none is unlimited. That means you want to show all the rows when you are specifying none. Alright. So let's try and copy this. Let's see if it copied over here. And let's try to run pd.get_option, and within single quotation display.max_rows. Yeah, so this time it has gave me the output. I'm not pretty sure why I did that, because I think I wrote this condition properly over there, but maybe I have done some mistake in while writing display or max_rows. So as we suspected that it is showing us first 30 and last 30 rows, so total 60 rows, and that assumptions have proved right. Similarly, if we want, I'll just copy this so that I don't have to write it again and make the mistake while writing, and display.max_columns, and while I do that, it shows us the 20 columns maximum that it can show. However, if you remember from our data set, we had 21 columns, right? So maybe it has just suppressed one column in those 3 different ellipses that I showed you. So how you can show all the columns? Let's say you have 50 columns and you really want to see it, all the 50 columns, but not just 20 columns. Then how you can do that? Well, the option is pd.set_option. It's pretty straightforward, as you can see. And again, you need to pass this same parameter, display_rows, copy, and I'll just paste it over here to avoid those mistakes. I say silly mistakes. So set underscore options. Now if you know the column numbers, like, or maximum rows number, so maybe in my case, let's say I want to specify 9,000 rows, but let's say this is dynamic and it keeps on shifting, like from 9,000 to maybe tomorrow 19,000, who knows, data grows exponentially. So what you can do is specify none, as it was shown over here, not present, shown over here, like none, this properties. So none basically says that all of the rows. So for example, max rows over here, none value means unlimited, and that's what we have done it over here. So we have specified none, and let's execute this. And now if I show you the orders, and this way, now it will take a couple of seconds because it is printing all the rows, not just the 60 rows. And after a couple of seconds, as you can see, this is now here, all of the rows. So earlier on 29th it has suppressed it, but now you can see 198, 214, all of the rows that are present here. But be very cautious when you are doing this, because based on the size of the data set, it can take a lot of time. So for me, it took around 3 or 4 seconds to print just the 8398 or 8399 rows. Alright, after that you can even set the options for max underscore columns. So I'll just copy this, and when I set that, you will not see the 3 ellipses that we are seeing here in the columns. So let's quickly wrap that up with max columns settings, columns and none. And once you do that and try to print orders, let me just show you 2 rows so that it's fast. And as you can see now, there is no ellipses like this, and we are getting all the column names, right? So this way you can set these settings and get the output in the desired format which you require. Next thing, after doing all of these settings, specifying that you need all the rows and all the columns, there may be a requirement that once you are starting fresh with a new data set, you may not want all of these options, right? Or maybe an extension to it. Once you have seen all of these rows and columns, there may be a situation that you no longer want to see all the rows and all the columns because it is taking a lot of time when it is printing, and you want to reset the options. So for that, again, it's pretty straightforward. You need to give the command pd.reset option and display dot max underscore rows. I hope I have specified it correctly, but let's see. Alright, it has not given me the error, so that means now we are good. Similarly, if you want, you can reset the option for columns, display dot max underscore columns, and press Ctrl Enter, and now it has been properly reset the options. And to see this thing in action, you can write order.head and just see the 2 rows, and see now you have the ellipses or 3 dots have come back as it was in the case of a default. So you have a lot of properties. If I just show you again, instead of going back, you have a lot of options. When you go into pd.describe underscore option, you get a number of options which you can visit. If I show you, it will take a long time, so I just wanted to show you the main ones. Like while doing the date setting, you want to say date first, or column space, or column header, justify left, right, all those formatting things which you probably need so that you can get the output in the desired format or in the desired layout. So that's pretty much all I have for you, and I'll meet you in the new video with a new topic. Hi there. In this video, I will show you pivot tables in Python Pandas. So most of you have seen the pivot tables which we usually create in Excel. So it's a cross tab and has the dimensions in the columns as well in rows, and data is present in the middle. So you must have seen a lot of cross tabs in the Pythons, as I mentioned, as well as in other business intelligence system. But let's see how you can create the similar cross tabs or pivot tables over here in the Python with the help of Python Pandas and the numpy array library. So for that, first of all, let's import the Panda library and numpy library. So import pandas as pd, import numpy as np. Alright, and once we have done that, let's go ahead and get our data set, which is orders. That's what we have been using. And here I have the script for you. So it's nothing but pd.read excel to read the Excel file and read the first sheet. So let's go ahead and execute this. And what we are doing over here is showing first two rows. So once we do that, here are our first two rows. And now let's try to create a pivot table with the help of let's say order priority. So to do that, what you need is pd dot pivot underscore table and specify the object orders and the column name, maybe sales, the numeric column name, and then the column name for the, let's say, order priority to get the dimension on the, let's say, the column or the rows, whatever is. So by default it comes on the rows if you are not specifying two columns. So we are just starting with one column and then we will move ahead with two columns. So let's specify order priority and let's get the aggregate function as np dot mean to get the average sales. Let's execute this. And here what we have from the pivot table, we have got just the simple table, which I would say, because in a cross tab you have columns over here as well, so or over here as part of this. So what we have just created is a simple table from the pivot table for the mean average sales and the order priority. Now let's move ahead, copy this and create the proper cross tab, and let's specify the second column. So let's say with order priority we want to see shipping mode, so the column name is ship mode, and you can execute this. But before I execute this, sometimes you are not aware what are those column names, so you can use one command. I'm just creating some space, which is orders.columns and hash. If you execute this, it will show you all of the columns name, and here is the ship mode. So even if you want, you can copy it from here and paste it over there, and so that you don't have to write it, and that way you will get all the column names. So all of these big column names like product subcategory, product based margin, you can directly put it over there. So for now I will just comment this and enable this and paste it over here. So now it's still in a form of a simple table, but have created a view of pivot table. Now let's see how you can take this shipping mode over here in the columns like a normal cross tab or a pivot table. So let's take this in a proper pivot table, and to do that, I'll just take it from there so that I don't have to really write all the syntax again. And what I want is two parameters, which is index is equals to order priority and columns is equals to ship mode. So that's pretty much all I need to do, and let's execute this. And now you can see you have got a proper cross tab from this function or from this settings. So index is order priority. Over here you have the index, and columns is equals to shipping mode. So shipping mode is here, and this central area is having the average value. So this way you can create your crosstab. And if you want to explore more, what you can do is come into this function, which is pivot table, press shift and 2 times press tab, and it will show you all of the features like fill value, what should you fill when there is a blank, and drop any margins. Yeah, margins is a good thing. I forgot to show you. So margins is equals to false, so by default it is false. So what it does is it creates the total in the end over here for the these rows, and for here for all the columns. So let's get margins is equals to true. True, and control enter, and now you can see you are getting this all as well, all here and all over here. So this is nothing but the average sales. For critical, average sales for high is this. Similarly, average sales for regular air is this, for express air is this, and for delivery truck is this. So delivery truck is for sure having the maximum sales, average sales. Another thing is that you want this name to be changed to something else, which is called subtotal or total. So what you can do is you can specify after margins, you can specify margin underscore name and specify, let's say, total, and press enter, and now you can get the total. So this way, if I come over here and press shift tab, you will get all of these different parameters related to this function, which is pd.pivot underscore table, and down there you will also get their explanations. So that's pretty much all I have for you in this video, and I'll meet you in the new video, the new topic. Hi there. In this video I will talk about how you can identify and drop null values. So null values are part of every real-time or the real-world data set, and you need to know what needs to be done with this null values. One of the ways is dropping the null values, and that's what we will be covering in this video. So first thing is how to identify and basically pinpoint where are the null values, and then processing it from the perspective of dropping it. So first of all, let's import our library, which is Panda. Import pandas as pd, and then let's get the data set which we are working, some superstore sales data set, and we will see whether there are any null values or not. So let's go ahead and execute this. It will take, okay, it's done. I thought it'd take a couple of seconds. Alright, after that, first thing is that when you are using orders, or once you have created the orders object for the sheet which contains orders information, you can use the method isNull by saying dot is, and I just press the tab after writing is, and you can see it is giving you is copy, is in, and is null. So the method we are interested in is null, so I'll press the tab again or the enter again. Once I execute this command, what it does is it shows us the entire data frame with the true and false value. So true indicates whether that particular cell or the intersection of row and column, which is actually a cell, is having a true value. If it is true, then the value is null in that cell. If it is false, that means value is not null. But what I'll do is I will just use hat, because there are some 8,300 odd rows in this data set, so it will take a couple of seconds but enlarge on the screen. So I'll just use hat, and now you can see on the first few observations those the output of the isNull function, and as you can see pretty much everything is false, and that is true because there is nothing null in these rows or columns. And then it becomes really interesting to see, then if we are not able to identify, or there are no nulls on the first few rows or the last few rows, because we can use head as well as tail, then where are the null values? So the interesting thing is using the function sum. What sum tells us is basically by the it takes a column on the column names in the one column and the sum of, or the count of, I would really say, into the next column. So how it does it is by counting true values, because true is indicated by 1 in the back end or at the back of the system. So if we are executing this, then you will see that where are we having the null values. So if I go down, so we have the null values only in the product based margin. Now let's identify those rows where for product based margin which are null. So for that, what you need to do is you need to filter or just get the product based margin within the orders object. So again, you need to write orders and write the product based margin. What I'll do, I'll just copy this and paste it over here. Alright, once you're done, and then write is null. Press enter. Shows me an error. Let me quickly check. Let me go down to see it in detail. Alright, key error, it's not an index. Okay, I think what we have done is, quickly I'll just show you, is I'll just put it over here. So basically what we are saying is only filter those rows where order is null. Earlier we were applying it on a data frame instead of the column name. Let's try to execute this. Yeah, now we got it. And if I go towards right, here are all the null values, only those rows which are having the null values. So if I see over here, there are 63 rows which are null, and as you can see, the product based margin, earlier it was 63 rows using the sum function what we got. Similar to is null, you have not null as well, which is the opposite of is null. So for example, if I say orders dot not null dot head and execute that, it will show true for all those rows which are not null and false which is null. So it depends on what kind of operation you want to get or what kind of output you want to get, and accordingly you can apply that operation. Whether is null will give these values as false and not null will get these values as true, and then you can count it with the help of the sum function and get the desired output. Now let's see how you can drop the null values. So before dropping, let's see what is the shape to identify number of rows and columns. So we have 8399 rows and 21 columns, and let's try to drop so orders dot drop NA, and you need to specify argument. If I show you the argument, going a little bit down, the main argument is this how is equals to any, and then x is 0 indicates the rows. If you change the 0 to 1, then it will be changed to columns, and then there is a threshold, subset, and in place. By default in place is false, so that whatever we will do it over here will not impact our original data frame. So if you want that it should impact, then make it true. Alright, first of all let's experiment with this how is equals to any, and then see the shape. So those 63 rows have been removed, and now the count is 8366, 21. Apart from any, the another parameter that you get is all. As you can see it over here, how is equals to any or all. If all values are NA, that means all values in the row are NA, then remove that row. So copy, paste, and I'll just press all. And if you don't know how I brought that parameter section, I have just pressed shift and 2 times tab, and here I'll get the information. Alright, and if I execute this, you get 839921, which is similar to our original. That means none of the rows have the null values in the entire row. So that's why you have got the output 8399. That means nothing have been dropped. After this, you can explore its another parameter, which is subset. It's sometimes very helpful. So what is happening over here is that it is looking at all the columns and checking whether in that particular row all the values for the respective columns are null or not. If you want, you can specify a subset. So what you can do is orders dot drop NA and use subset, and subset is equals to, you need to specify the column name within the brackets and then say how is equals to all and then shape. Well, sometimes it's little difficult to go up and down and see the column name. So what I usually do is I just comment it up and use the method, alright, columns CO, and it gives me the column name. Now I can choose whatever column I want. So maybe I want, let's say, customer name and province. These are the two columns and it's in the required format, so I don't have to do a lot of typing over here, and I just paste it over there. And now I just comment this up and uncomment this and execute. And now you can see that in subset, when I have taken just the subset, that means not the entire row but only for these two columns, if it has the null values in that particular row, then those rows will be dropped. And since it does not have those null values, you are getting the entire data set. After that, you have another parameter for drop NA, which is threshold. So if I show you, threshold is equals to none, and let's see the definition what is given over here. If I go down, require that many non-NA values. That means in a normal English sentence, if I tell you, so threshold is equals to 3 will basically indicate that if any row has more than 3 values as a null values, then remove those rows. But if there are any 2 values which are null or 3 values in a particular row which are null, then don't drop those rows, because there may be a scenario that there are a lot of nulls and you just want to specify a threshold that beyond a certain threshold just drop all those rows, because then it does not make any sense. So for that you can specify how is equals to any, and threshold is equals to 1. 1 will indicate that if a particular row is having one value as a null value in a particular cell, then don't drop that. But if it is 2 or 3, in that 2 or 3 values which are null, then drop those values. Alright, so if I just go and look at shape, and again we get this because there is just one null value which is in a product based margin, and since it is coming under this threshold, that's why it has not dropped it. So I hope you have found all of these parameters useful, and I'll meet you in the new video, the new topic. Hi there. In this video, I will talk about filling up the NA values. So in the last video, you must have seen how you can identify and drop the null values. That's one of the ways to treat your null values or the missing values. But another way to treat the null values or the missing values is to fill them up. And here in this video, I will show you a couple of different methods by which you can fill the null values. So first of all, let's import our libraries, which is Pandas as PD, and we will import another library which is numpy as np, because I will just create a custom series which will having the nan or a number value, which we can create it by using np.nan. So I'll just execute that, and I will just create the object which is null values by creating pd.series, and here I can specify some dummy numbers, which can use this parenthesis and then these brackets, and say let's say 1 comma np.nan comma 2 comma np dot nan 3 4 and another missing value, and let's say 8 for example, and let's go ahead and execute this. Alright, now it's fine. So if you just print the values, you will see that 1 nan, which is not a number, 2 3 nan, then not a null one. So you have a couple of different methods within Python to take care of. So the methods like forward fill and backfill. So what it does is it takes the first value in case of forward fill, and based on what you have specified, it will going to fill up that value. So here in this case 1 is here, np.n will have 1. Now it has seen second value, then it will fill up this value. In case of backward fill, it will see the last value and fill up the values above which are null. So let's see these things in action. Alright, so I will write null values dot fill na. I just press the tab, and it has some properties, and the method we are looking at here is this. Right now the method is none, but if I show you the values for method, so you have bfill, ffill, pad, none. The most important are bfill and ffill, which I will just show you. Pad is I think pretty much similar to ffill, and backfill is bfill. So let's go ahead, and method is equals to ffill and press enter, and now you can see for that index 1, earlier it was nan and now it has 1. So in case of forward fill, as I explained it earlier, it is taking up the values which is right above this null value and filling up that particular piece. Similarly, in case of 2, the 2 is coming over here for third index number, which was earlier null. When in case of this fifth index number, the value is 4, and right after that 2 values are null. But now you can see the 6 and 7 values are having 4 and 4. Now let's replicate it or reverse it using bfill, and now you can see it's completely opposite. Alright, one other thing is when you are using fill na, let's say you don't need any value, but you just want to replicate the missing values with let's say 0. So you can just simply specify 0, and now in this case you will see that you are getting 0 for all those values. So this way you can replicate 0 with the help of, and that will help you when you are doing some operations which require that, especially in machine learning, which requires that there should not be any missing values. So it's better to just replicate it with the 0 and don't have any missing values. Another method that you can use is, and it's pretty interesting because I think in many cases it gets used, using the average value, np.mean. Alright, I just need to specify, that's why it is giving a little bit odd output, just the function mean, and I need to specify null underscore values. Now you can see the mean value 3.6 is replicated all over the place. So this way you have np.mean, and there are other methods as well within the np, say for example sum and min, max, and other things by which you can replicate the null values. That ideally that is based on how your data set is and your research problem. Now let's use another parameter. So far we have been using method parameters ffill, and now I'm using limit parameter and specifying 1. So what it does is, after index 0 there was a null value which was the first value, and it will properly pop up. But in case of index number 4 you had 2 missing values. So in that case, or maybe it was I think 5, because I can see 3.6 coming 2 times. So for index number 5, you have, after that you had 2 missing values, so it will just fill up the value for 6th one, but it will not fill the value for 7th one. And that's what limit means, that just add or just fill the consecutive value or the next appearing null value. So let's go ahead and see it in action. Alright, something I have I guess silly mistake. Who will write fill an A? Okay. Now you can see after 5 you have 6 as 4, but for the 7th value there is an AN because we have specified limit is equals to 1. That means just fill the very next value, not the other missing values. The next and very interesting method to fill the null values is interpolate. Null values dot, if I write interpolate and just execute this, you will see some interesting patterns, like for 1, 1.5, 2, 2.5, 3, 4, 5.33, 6.66. So interpolate is basically a statistical term, and especially useful in such cases where you have the data, let's say specifically in case of distributed time series, the data is distributed over time period, and for a couple of time periods the data is missing. So what it does is it looks at the internal trend of the data about how the values have been distributed, what is the interval, and based on that trend and interval it basically fills up the value. So what it sees over here is that there is first value, there is value 1 for index 0, for index 1 there is null, and for index 2 there is 2. So between 1 and 2 probably you may be having 1.5 based on the trend. Similarly between 2 and 3, 2.5. Now between 4 and 8 you have 2 null values, so that's why it has changed the equation a little bit and saying 5.33 and 6.667, and then filling up the missing values. So this is pretty interesting, and it follows the interval or the trend of your series. Say for example, if you have, let's say, so if I just show you by creating another series, interpolate underscore series is equals to pd dot series, and write 1 comma np dot an comma, let's say 5 comma np dot nan comma 9 comma np dot nan comma 13. So you can see that I have the interval of 4 over here. So between 1 and 5 4 values, 5 and 9 again 4 values. So that way I have just created a simple series which is following up some sort of an interval, proper interval, and I'll just execute that, and I will write interpolate underscore series dot interpolate and execute that, and you will see that 1, and after that it has written 3, and then 5, and then 7, and then 9, and then 11 and 13. So this way it has identified a trend that after between 1 and 3 there is an interval of an interval which indicates that probably it is 2 steps or 3, a regular interval like arithmetic progression it is following, and that way it has populated 1 after 3 and 5 and then 7 and then 9 and 11. So that way you can see how it is how it can help you to really populate a bit of a realistic series or a realistic number based on the trend your data is following. So that's about it, and you can see its different method, how the limit direction, the downcast method, as you can see it is linear. I think there can be geometric method if I'm not wrong, or a couple of others, but you can explore. And then you have limit and in place. So this way you can fill up your any values and get the desired output. So I'll meet you in the new video, the new topic. Hi there, this is Abhishek, and in this video I will talk about how you can create dummy variables. So dummy variables are helpful whenever you are doing any machine learning task, because most of the machine learning, or I would say all of the machine learning libraries, basically takes the numerical data from learning from the existing data and build a machine learning model on top of it after it has learned. But in a real world data set, there are chances, or most of the times I would say, you have the combination of numeric data as well as categorical data. So data like where you have, let's say, country information, products information, shipping information, all of that thing. So let's see this thing in action, and I'll just show you what I meant by that. So first of all, let's import our library, which is import pandas. We are importing as PD so that we don't have to write pandas all the time whenever we are calling its functions or methods or properties. So I'll just go ahead and execute that, and I will write what I'm doing is simply reading an Excel file using pd.read Excel function, and this is the path of the file, and 0 indicates that I want to read the first sheet of the workbook, and then I am displaying the first 2 rows of the sheet by using order.head 2. Alright, let's execute this and it will show us the 2 values. Alright, now you will see that we have columns like order priority. It contains the categorical data in character form. Similarly, shipping mode, then you have customer name, province, region. So most of the time things like order priority as well as shipping mode gives us a lot of values. So generally their values are repetitive. So for each of the order, whether it's low, high or medium, what kind of priority is, and like shipping mode, regular air, delivery truck, or by some other mean. So these values are repeating and sometimes unveil a lot of valuable information about, let's say for example, you want to identify those orders where your company is not having a good revenue, from which shipping mode they have been shipped to, or what have been the order priority, so that you can identify the weights by learning from the data using a machine learning model and then move ahead with the predictions. So to learn it, you need to convert the order priority or shipping mode or any other column of your interest into some sort of a numerical form, and that's why you need to create dummy values. So things like you assign low to 0, high to 1, and some other value to something else. So what we do in case of dummy variables is for each of the row we will identify the value low and assign it to the 1, and for rest of the values like you have high or medium, it will be 0. So how you can do that, I'll just show you in action so that you can better understand what I meant by assigning the 1 and to rest of the zeros, rest of the values to zeros. And there are 2 ways by which you can create dummy variables. First way is to pick out the data series, like in this case order priority, and create a dummy variables and then attach it back to the data set. So let's do that. So we will write pandas library pd dot get underscore dummies, and then we will write the name of the data set and the column or the series. So series here is order priority, and we will just get the first few observations, and I'll press Ctrl Enter, and now you will see that for order priority it has given us a value for critical, high, low, medium, and not specified. And for the first row, where the index is 0, the priority is low, and that's why the value is indicated as 1. So if I go back above and show you the first row, so for 0 index it is low, and that's why it has been identified with 1. So for rest of the categories it is 0, and all of these columns we need to add it to this data set. So let's see the the same example with shipping mode just to get much better clarity. So I will just copy this and paste it over here, and then instead of order priority I can use any other column. So here in this case shipping mode, ship mode, and press enter, and here is my, now I've got my dummy values. So for index 0, this is the it has gone by regular air, so that's why it is indicated by 1, and rest of the other categories are indicated as zeros. So this is how it identifies and creates a new column by converting into a numeric form, so that the machine learning models can learn from the numeric data. Now one important thing to note, that whenever we are creating the dummy variables, so for example in this case delivery truck, express air and regular air, we will always take n minus 1 columns. So we have value of n is here 3, 1, 2, 3, because we have 3 columns, and the value we will take is n minus 1, that means 2. The 2 columns we will consider. So for example, let's say if the shipping mode is not delivery truck, in this case here it is 0, so it is not delivery truck, and it is not express air. If none of these are present, then by default it has to be regular air. So because we know this already by identifying that it is not delivery truck and it is not express air, it has to be regular air. That's why we don't need this column, and that's also one of the requirements for the machine learning models as well. So always remember that whenever you are creating dummy variables and adding it to your data set, always take n minus 1 values, because this does not make any sense once you already know that the order has not been delivered by delivery truck or express air. Then it will obviously be the third option. So how you can remove the first column and get back the rest of the data? Well, let's see this example here itself. I'll just copy this entire piece and paste it over here. I'll just go a little bit down and I'll remove the head. And one thing we need to do where we select the rows, which is ILOC, that means specifying the integer position to select the columns and rows. And first we want all the rows, so I will specify column. That means I do not want to remove any row, but let's say I want to remove this first column, so I will write 1, index number 1 and colon, and this will indicate for columns start from the index position 1, which is this, and go until the end. And end is specified. Once we don't have anything over here, it will go until the end. If we specify, let's say 2, it will go until here. So let's say if you have rest of the other columns, it will not take those, but only those 2 ones. Since we don't have any other column after that, we will just specify nothing after the column, and let's take the head of it so that it is not showing us the entire data frame. Now as you can see, the delivery truck has been removed and we have express air and regular air. So now in this case, for index 1, express air is 0 and regular air is 0, so it has to be delivery truck, and that's what it is here. So that's how you can identify that why you don't need one column and why you should always have n minus 1 values. Now let's take these dummy values and add it into the data set. So for that, let's create the object which will contain this, and after it is having the dummy values, let's add it into the data set. Now let's see pd that addition, pd dot concat, and within this you will write orders comma ship underscore dummy, because that's what, and axis is equals to 1 because you want to add columns. And if I press shift tab, and you will see that it does not have in place column or the in place. So what we need to do is we need to store it into the object. So orders is equals to, and let's see the head. Alright, the column should be in the end, so I think it's pretty big, so I'll just take 2 observations so that it's in one screen only. And if I go towards right here, alright, because I added it 2 times, so it has added it multiple times, so we can remove that, already by using the iloc you can do that. But idea is I wanted to give you is this, that express air and regular air is added by using the concat function. Alright, let's move ahead. So next thing I want to show you that how you can achieve this entire piece in just one command. So what we need to do is we need to write pt dot get underscore dummies and orders, because that's where we want to do that, and columns is equals to, let's say I want order priority, just to be in sync what we did earlier, and I want ship mode. Alright, and so these are the columns on which I want to create dummy values, and I want to drop the first column, so I will write true. Alright, and use head 2 observations. So enter, and now you will see the order priority is added, order priority high, order priority low, order priority medium, order priority not specified, and ship mode, express air and regular air. So from here to here, these new columns have been created and added into your data set. And I'll just see that whether it has in place parameter or not. So yeah, you need to use again like this, orders is equals to make the changes happen into your data set. So that's about it, how you can create dummy values and go ahead with the machine learning task. So that's pretty much all I have, and I'll meet you in the new video, the new topic. Hi there, in this video I will show you some of the date functions and properties that are available within Pandas. Alright, so first of all, let's add the library, which is Pandas as pt, and let's go ahead and import the orders sheet from our sales sheet, and that is what we have been using as an example. After that, let's see the data types. So this will show you that row ID is int64 and the interest is on the date, and it has been shown, or it has imported the dates properly and formatted it properly without specifying any parameter or anything. And sometimes it happens that it is mentioned as object and not as a proper date, maybe because of mix up of date formats and things like that. So if you have a situation where it is not formatted, then you can use the to_date function to basically convert into a date. So since we have proper dates over here, so we don't need to convert it, but let's go ahead and see some of its objects and properties, some methods and properties. So first of all, let's take the order date and let's use dt sublibrary, and let's use day of year method dot head. Let's see this. Alright, it gives series subject is not called. Okay, I think it's just the property, not the method. Let's see this now. Yeah, so for first row, the day of year is 286. For first row, the second row, the day of year is 275, and so on and so forth. So this is the method that you can use to identify which day of year it is based on the date that you have. Sometimes due to some reasons you are interested in knowing what is a weekday name of a particular date. So whether it's a Sunday, Monday or Wednesday, what it is. So what we can use is dot weekday underscore name dot head, and it will show you whether it is Wednesday or Monday or Sunday, which day is occurring, which weekday is occurring on the on that particular date. And like day of year, you also have a property called week of year as well. So instead of saying day of year, you go week of year, and that will show you what is the week number within that year. So you have 52 weeks, and it will show you anywhere between 1 to 52 for that particular order date. Also, if you are interested in knowing the day of week, the number, like we have got the weekday name, you have something day of week dot head. So whether it's the second day, first day, that means that is indicated 0, or the last day, which is indicated with the 6. And as you can compare from weekday name, the Monday is the first day and it's been indicated with 0. So 0 is Monday, Tuesday is 1, and Wednesday will be 2, and that's why you have it 2 over here. And Sunday, as you can see, is the last day, has been indicated with the 6. So that's the numbering that you need to follow. Now many times when the dates are given and you need to create some sort of a reports or dashboard, you have to extract year information or the month information from that date's value. So how you can do that and create a new column in your data set? It's by saying orders dot year is equals to order date dot dt dot year. And now let's see, orders dot year dot value score counts. So what it has done, it has created the first of all year column, and then we are counting how many values are present in each of the year. So this way your years are starting from 2009 and going up till the 2011, and these are the values as per the count you have, or the number of rows that you have within each year. Similarly, you can fetch the month information as well. So if I just copy this entire piece so that I don't have to write it again, and if I just go a little bit down there and say I want month information, I will change it to month, and here also month, and it will give me the month information, so from 1 to 12, and tell me how many rows it has. Alright, finally I want to show you the so I have a documentation, and this is the link for date time properties. So if I just go to this link, it will show me the date time properties. So like we have been using series.dt.date, so we have used year, we have used month. So there is similarly you have day, hour, minute, second, microsecond, nanosecond. Similarly for week of year, day of week, weekday, week name, all of these different properties, which is pretty straightforward to work with the dates and create new dimensions or the new columns for your data analysis. And that's pretty much all I have for you in this video. I'll meet you in the new video, the new topic. Hi there. In this video, I will talk about how you can identify and remove duplicate reports in Python using the Pandas library. So let's go ahead and import the Pandas library. First of all, import pandas spd, and I will use the data set which I've been using in so many previous videos, which is a sample superstore sales data containing sales of a superstore, and then after reading it from the Excel file using the function pd.readExcel and storing that sheet into the orders, I am viewing the top 2 rows. So let's go ahead and execute that. Alright, here are my top top, but the first two rows, I should really say, first two rows in the data set, because top indicates that top rows by sales or discount. So that's not it is. It is first two rows in the data set. All right. Once we are here, we will see that there will be a lot of duplicate values. So for example, multiple customer names are occurring multiple times, and similarly, let's say product category, customer segment, and all of those things. But sometimes these are necessary, and you really don't want to remove that because they actually represent the data which should be there in your data set. But let's say, for example, you don't have a requirement where you need the multiple customer names in the data set. You just want to have a unique one, maybe for some research requirement or something. You want to get to know about your data set by looking at the unique customer name, or maybe for some other reasons you just need the unique values for a particular column. So how we can do that, I'll show you in this video, which is pretty straightforward using the methods given in the Pandas library. So the first thing is looking at the entire data set, which is in the object orders, and using the method duplicated. What it will do that wherever it will identify the duplicate row, it will mark it as duplicate and show true or false based on whether it is a duplicate or not. So I'll just go ahead and execute this. And here, as you can see, there are a lot of values which are coming, and it will go until the end. And by default, it will show that all of them are false. That means there is no duplicate row. That means all the contents in these entire cells. So if I just go up a little bit up and show you. Okay, I'm going it's a little slow. All right. So this entire row is getting compared with this row, and then it is indicating whether it is a duplicate row or not. All right. So in our case, the good thing is no two rows are duplicated because it is returning false. Now the next thing is, let's say you want to, if let's say there were some true values inside that, because not all the values have been shown. I think first 30 and last 30 values have been shown over here, and as you can see, there will be 3 dots. All right. Okay, here it is. After 29, you have 3 dots, and so there may be a scenario that you may have a true over here. So let's say if you want to know about that, first thing is getting the count, how many rows are actually duplicated. So for that, again, orders dot duplicated dot sum. Sum basically true here in the back of this program or this text is indicated by 1 and false by 0, and sum will sum all the ones, that means the trues, and give us how many duplicated rows are there. So if I go ahead and execute that, you will see there are no rows which are duplicated. All right. Now let's go a little bit deeper. Let's say, for example, you want to see that in a particular column or a series, how many duplicate values are there. So let's say, for example, orders in customer name, for example, you want to see how many duplicated rows are there. And I'll just use sum. So there are 7604 values which are duplicated because the same customers are giving you the order, or maybe the order is spread across multiple products, and multiple products are in multiple lines, and that's why the customer name is coming, and this 7604 is indicating the value that you have number of duplicate customers. If you want to filter this data set where all the customer names are coming, what you can do is copy this entire piece, this previous command, and write orders, and within that paste it. So what it is doing is, wherever the true is coming, it will filter out the data set by that. And since it will be so many rows, 7604, so let's see the first 2 rows. So head and 2. Alright, here we are having the first 2 rows which are duplicated. So row number 2 0, 1, 2, so basically the row number 3 and row number 6. These are the rows which are duplicated over here. And if you don't use head, you will get the entire data set. The next thing is that sometimes there is a requirement that, or first of all, the default thing is that first row is not removed, and if the second row is duplicated, it will be removed or filtered here in this case. But there is an argument, so if I press shift tab tab, you will see that keep first. This is a default argument, that means keep the first row, and if the second row is duplicate, then remove that row. But there is an option, if you go down, keep first, last and false, and by default is first. So probably if you want to use the last row in this data set, you can use keep is equals to last. So in this case, since we are looking at the last row that we want to keep it, you are getting a different set of results. Apart from this, if you want to include all the duplicate rows and no change into the data set, and if I press shift tab tab, you will see that there is an argument which is false, which means that you want to include all the rows, duplicate rows. Alright, let's move ahead. Let's talk about how you can drop the duplicates. So for example, if I look at the shape of the orders data set, there are 8399 rows and 21 columns. And similarly, if I look at orders.customer name and its shape, you will see that there are 8399 rows as they are indicated in the entire data set. There are 8399 customer names, so there is no null, and all the values are properly populated in that column. And since it is a first only column, so that's why you don't have a value over here after the comma. Alright, let's say if I want to duplicate, remove the duplicate customer name. So I'll write dot customer name dot drop underscore duplicate duplicates. And let's look at the shape. So there are 795 rows which you want, which you are getting are dropped. After dropping it, you get 795 rows which are of unique customer name there in the data set. After that, you have, in a similar way, if you see this command, and if I go here and press shift tab tab, you will see again a couple of arguments. First of all, the subset. Subset is similar to that if you want to just use couple of columns. So maybe let's say drop underscore duplicate subset, and I want to indicate that look at just couple of columns. So maybe I don't want to specify it over here. I want to specify it over here, that look at just customer name, or maybe some other column name, maybe ship mode. So this will subset and look at only these two column names when dropping the duplicates. Alright, and if I show you the other parameter, shift tab tab, the next parameter is keep is equals to first. So as I indicated it earlier, that by default it is first, but if you want, you can use the last. That means drop the last row because you are dropping the duplicates, and if you want, you can drop the first row, or you can use the false one. That means drop all duplicates as it is indicated over here. Alright, and finally you have the parameter which is in place is equals to false. So what it indicates is whenever you are doing this operation, it is not impacting your data set. But if you want that whatever operations you are performing on this series getting impacted on your data set, you need to use in place is equals to true. So whatever changes, drop duplicates or anything else you are doing related to this, like keep first or subset, by indicating in place is equals to true, your final data set or the data set that you are using will be having that changes once you finally view it. So that's about identifying the duplicates and finally dropping it. and this is pretty much all I have for you, and I'll meet you in the new video, the new topic. Hi there. In this video, I will talk about how you can align two different series or data frames. So to do that, first of all, let's import the libraries, which is Pandas SPD. We will import numpy library as well because we need to some operations, as well as from Pandas we will import series and data frame. So let's go ahead and execute that, and the libraries have been imported. After that, we will create two different series. So let's create series 1 as series, and within that let's specify some observation, simple one, 0, 1, 2, 3, 4, 5. So these are like 6 observations, and let's give an index also as A, B, C. Let's say next one is E and F. So this is 1, 2, 3, 4, 5, and one more, G. Alright, and let's print it. So here is our series 0, 1, 2, 3, 4, 5, and related to that the index values are here A, B, C, E, F, G. So let's go ahead and create another one. I'll just copy this so that I don't have to write it again, most of the pieces. So let's start maybe to see this thing in action. Let's start 3, 4, 5, and maybe 6 and 7 and 8. Right, so let's give it a name as A, B, and let's say D, let's say F, let's say H and I, just to do the experiment, and change the name of the series to 2. Alright, let's go ahead and execute this. So here we have our two different series. First series is straightforward, 0, 1, 2, 3, 4, 5, A, B, C. D is missing, and D we have got over here in series 2. So first thing is, what happens if we add these series? So SER1 plus SER2. Let's execute this. And if you see that wherever it has identified the first series value A, B into the second series, and similarly in second series we did not have C, so if any of the value is missing, it has indicated that not a number, right? So whenever you are playing with your data frame, doing some data analysis, and you are getting some weird result when you are trying to add the two different series or trying to perform some operations, I think you need to go back to basics and see why it is. So maybe the reason about their internal structure, or maybe specifying or using the right function to do that, and we will see in a couple of minutes that how we can correct this behavior. But idea is to show you what happens when we do that. Generally our thinking is, if you are coming from the SQL or Excel background, that there should be A, B, and C should come as it is, like 2, and for D it should be 5, and so on and so forth. And but that's not what it is happening here. So it's an important to get an idea what really happens when you add two different series. After this, let's try to see or perform the similar sort of operation on a data frame as well. So df1 maybe, and specify data frame, and here let's use np.arrange and 4 values, that means 0, 1, 2, 3, 4, and let's arrange it in a 2 by 2 matrix. So reshape 2, 2, that means 2 rows and 2 columns, and let's give 2 dummy names columns, and let's specify within the list AB. So this way first column will get the value A and another column will get a value B. Alright, once you do that, then you can specify the index, and let's give the index as prod1 and prod2 just so that there is a clear differentiation between the characters, the columns and the rows. Alright, let's go ahead and print this. And here we have AB, product 1, product 2. Let's create a different data frame and paste it over here. And then go ahead, change the name first of all to 2. And let's create maybe 9. And now 3 comma 3 metric, and maybe in this case A, D and C, and prod 1, let's say prod 3 and prod 5. Alright, so here you have A, D, C, A and B, prod 1, prod 2, prod 1, 3 and 5, so that we can see all of this operation when we are adding it to different data frames, how the result is coming. And if you are thinking about how we got the last results and similar way it will give it here, then you're right. df1 plus df2, and let's go ahead and execute this. And as you must have expected, that's how the results are coming for you. So only prod 1, which is common in both the cases, for column A you are getting the output, and for the rest of the values it has become NaN. Now what happens is, when we get a result like this and there are a lot of null values, we always want to remove that, or at least we try to get default values. So for example, what happens if, let's say, we want to get all the values which are over here, so that they are not getting impacted when you are adding it and finally giving you the null value. So what you can do is, you can use the function which is df1.add to add it properly. And what you want to add is df2, and you want to fill underscore value with 0. So what I will suggest is, take a pause or pause this video and try to see what should be the output. So what is happening over here is, we are saying add df2, fill value is equals to 0. So think about this, read little bit of documentation by pressing shift tab, and it will give you the documentation of what happens when you add it, and the columns and other things, and down there it has the parameters. And try to get the output before running this command. So I hope you must have gone through with this and try to figure it out, but if not, let's go ahead and see this. Shift enter, and now you are getting the value of 0. For the B you are getting 1, 2 and 1 for both C and D. Prod 2, since it is not available, you are getting 2 and 3 from the first metric. For prod 3, again B is not available, so you are getting 3, 5 and 4. And for product 5 we are getting the value 6, 8 and 7. So everywhere the value is coming, and wherever it could not identify the products or the column, it has given the value 0, so that there should not be any issue when you are adding the two numbers or two data frames. After this, let's try to see what happens if we try to add or subtract a series into a data frame. So here we have the second data frame, which has the value ADC as the columns, and these are the row 1 or the index 0, 1 and 2, and try to get, let's say we try to get the index 2 value over here and create a series based on that. So for that, let's take a series third, and df2 dot ix and 1 and series 3. So here is the value A, D and C, 3, 4 and 5 for product 3, 3, 5 and 4. So for D is 4, so that's why D is 4 and C is 5. So what if we try to, let's say, subtract it from this? So what we are doing is need to say data frame 2 to see this, show this operation, and press enter. So as you might have suspected, based on that the second row that we took, it has subtracted the values from the second row and giving you the output 0, 0, 0. So that's about how you can do the data alignment and see this thing in action, and this is something sometimes very helpful when you are not getting the results as expected, when you are doing such sort of an alignment by doing addition or subtraction. So you can always come to these basics and see the things in a small perspective or with a small data set to see what is really going on in the back end of the calculation, and whether this is making the or coming as per the expectation which you need from a larger data frame. So that's about it, and I will meet you in the new video, the new topic. Hi there. In this video I will talk about the ranking in Python's data frame. So ranking is a common procedure whenever you are doing any data manipulation or trying to figure out whether, say for example, profit is high or low based on some sort of ranking, or even sometimes management is interested in knowing what are the top 10 products or bottom 10 products and things like that. And for that you need to do the ranking. So I will show you how you can rank the data, and then we will just go through some of its parameters to further fine-tune your ranking. So first of all, importing the Pandas libraries as always, and then use the data frame, which is orders sheet. I am continuously using this data set, and in the first few videos even I have shared the data set, but I will paste the link over in this video as well so that you can use it. Alright, so what we are doing over here is we are reading the Excel file using the pd. So pd is coming from here, pd.read_excel, and we are reading the first sheet, which is the order sheet in this workbook. So once we are done with that, let's see the first two observations. Overhead is helpful in viewing the first 5 observations if we are not specifying anything over here. But if we specify any number, let's say 2 in this case, then it will show the first two observations from the data frame. Alright, let's execute this, and here we have the columns from this data frame. Since it has a lot of columns, some of the columns have been hidden, and we can see we have sales, discount, profit, and now you can do the ranking based on these numeric columns. So for example, you want to see the top sales or top 2 sales and things like that, then you can first rank and then use the head. Similarly, if you want to see the profit by customer or by province or region, or simply like profit, where is the maximum profit coming from, simply not by any dimension, but sorting it or ranking it from the perspective that where is the highest, wherever it is highest profit, just give it a first rank. So how you can do this is by using the rank method. So first of all, what I'll do is I will simply say that orders dot rank is a function, and it has some argument. If I show you, like it has access, method, numeric only, any underscore option, and you can see all these arguments by pressing shift and 2 times tab. So shift tab, and it will show you these arguments, and then it has some definitions as well if you go down and all. Alright, so if I simply say orders.rank, that means simply apply the rank on the entire data set, on the entire columns. So if I just go ahead and execute that, it will take all of these columns that it has along with province, regions, convert into a numeric, whatever the numeric form is, and do the ranking in the ascending order. But this is a bit complex if you try to interpret it. So that's why you always have the option of taking any column, in this case let's say profit, taking any column and then do the ranking and apply it on the data set. Alright, so for that let's create column rank by profit so that it becomes part of this data set, and then say orders, and then you need to specify the column name, which is profit, and then say rank. Alright, now if I show you the arguments again by pressing shift tab, by default ascending is true, that means lowest value will be ranked first. So what we will do is we will say ascending is equals to false, and in that way the highest value will get the rank first. Alright, let's go ahead and execute that. So it's executed, and let's see orders dot head. First five observations. Okay, so here we have minus 213. If I show you a couple of more rows, then 457, and then you have 46, 1198, and then 30. And if I go towards right, these are the respective rank. So 555, 555 is giving to the profit of 1198, and lower rank to 30, 3248. So that's in the right direction. If we want that highest value should be ranked first. And if I show you the column name by going up, rank by profit has now become part of this data frame. Now the next logical question that can come into the mind is sorting these ranks. So generally we want to see the first rank is coming over here, then the second rank, and then the third rank. So for that you can use the sort underscore values. So if I say orders dot sort underscore values and specify the column by which you want to sort profit, and then you have another argument saying ascending is equals to true. Let's make it false because we have the rank also in the descending order. And let's take first few observation. Alright, if I go down, and so here is the maximum profit 27,220, and if I go towards right by scrolling it from here, then we have the rank 1, 2, 3, 4, 5, so on and so forth. So that's about how you can first of all define the rank for each of the column and then sort it by the these values. Then you have a couple of other parameters as well. Say for example ascending, if I go up a little bit, because this is sort values parameter. Alright, where are you? Little bit up. Okay, so here we have figured it out, the rank by profit, saying rank ascending is equals to false. So this is one parameter, but if I press shift tab, you will see a couple of other parameters. So first parameter is the axis is equals to 0. That means this ranking is getting applied on the rows. So if you see, this is the value, or this is the rank for the first row, this is the rank for the second row. So this is by default axis is equals to 0, so rows are getting ranked. Whereas if you want by column, let's say this column and then this column, you want to compare it by column and then want to get a rank, then you need to specify the axis is equals to 1. Okay. Then second argument is about method is equals to average, and basically it is that if the two rows are having the same value, then the average method will be used to rank those two rows. But you have couple of other parameter values like min, max, first, and tens, and you can basically experiment with that, and it's pretty straightforward. As you can see, average is basically average rank of group, minimum is lowest rank in group, maximum is highest rank in group, and so on and so forth. So you can experiment it, because condition may change and you may want maybe min, max, based on that ranking if you want. Numeric only is equals to none, because generally we want to apply the ranking is equal on the numeric data, but none indicates that even apart from numeric, it also consider the character data by converting into numeric and then applying the sorting. So by default it is none, and I will just suggest to keep it that way, because mostly you will indicate it by the column name how you want to sort it. Then you have the option of any underscore option is equals to keep. So this is helpful in scenarios if your data set is having the any values, and in that case you have three options if I'm not wrong. So if I go down, yeah, keep, top and bottom. So keep is basically simply saying keeping the any values where they are. If we, let's say, specify keep is equals to top, then in that case smallest rank in case of ascending, and in case of bottom we will say the output will be smallest rank if descending. So that means they will get the any value will get the smallest rank, or in this case smallest when you are ascending it. So you can experiment with that and get the data in your desired format. And ascending we have already seen, and the final parameter that we have is PCT, the percentage, and it's simply compute percentage rank of data, right? So basically wherever the highest data value is, so highest profit is, will get the highest percentage, and then the lower one for the subsequent values. So that's about the rank method that you have for the data frames in Pandas, and to do the ranking in your dataset. So that's pretty much all I have for you, and I'll meet you in the new video, the new topic. Hi there. In this video I will talk about how you can work with the hierarchies that are present within the index. So if you have seen my previous videos, we have covered in couple of few videos we have talked about indexes, and in this video first of all I will show you about the index hierarchy, and then how we can perform some common operations like selecting data or sorting or summing the values based on those indexed in their hierarchies. Alright, so first thing is to import the library. Import pandas as pd, execute that, and then create a series, maybe ser1, just a name we can take, and pd.series, and let's give some values 1 2 3 4 5, maybe 6, so it's just some dummy values, and let's give index, and let's give to create a hierarchy of index we need to give two different indexes. So first one is, let's say 1 1 1 1 2 2 2, and maybe the next one is A B C, again A B C. Alright, if you look at this index, this one is a first index, so that's why, or a high level index having the value 1, and then this is a lower level index, second level index, this is having the value ABC, and again repetition of ABC. That means with 1 ABC is assigned, with 2 again ABC is assigned, so there is some sort of hierarchy which is present. So let's go ahead and see the output. So here is the output. As I mentioned, this is 1 and 2 is the upper level hierarchy, and ABC is basically second level hierarchy, and then you have their respective values 1 2 3 4 5 6. Now the first thing is that probably you want to give names to these hierarchies so that they are more meaningful. So maybe in this case ser1 dot index dot names is equals to indx underscore 0, indicates the first index, indx underscore 1. So this is index level 0, level 1, so just to give you an idea. And let's print it, and as you can see we have the indexes over here, indx 0 1, the names that we have given, and then their respective values. Let's say you want to access any specific index, maybe 1 or 2. So what you can do is simply pass the parameter ser1, and so this should be ser1 and then the index value 1, and it will give you the output for index 1 ABC. Similarly, if you pass the index level 2, you will get the second index. So that way you can access the first level index. But there may be situations where you need to access the index which is at level 2. So what you can do is simply, maybe I'll just copy this and paste it down there. So we need to first of all use colon, then comma, and then the value a, and let's access this. And with this way you can access a value. So first is 1. So if I go a little bit up, so first a value is 1, second a value is 4, and that's what you are getting for value 1 and 4 for the index. So this is about accessing the data based on the index levels or index names that are present for your series. Now let's see how you can convert this series into a data frame. So for that, maybe we can create a data frame 1 and use ser1 and use the column unstack. Alright, let's print it. And this way, if you will see, your ABC is coming over here in the column. So one of the straightforward way about how you can unstack it. Let's see the parameter that it has by pressing Shift Tab, and you can specify the level here in this case -1, which has been given. Fill value, so in case if you have any values you want to fill with 0 or something else, you can basically specify those parameters. So you can view this by going there in the parenthesis and pressing Shift and then 2 times Tab key. Alright, let's come out from here. Now let's see how we can swap the levels of series. So if I go up and show you the series, what probably you may want to do is swap these levels. So ABC is coming first and then the second one. Alright, to do that there is a very straightforward method. ser1 dot swap level. If I press enter, here you are. Those levels have, if you see, one was coming at the very first time and this ABC was coming second, but now it has been swapped. So this way, whenever you have a need or requirement where you need to swap the level, you can very straightforward specify swap level, and if you go press Shift Tab, you will again see that it can take 3 parameters which you can customize based on the values that it takes. But it's pretty straightforward. I mean, simply by specifying it, it's pretty intuitive that it will swap the levels which are present here in the series. After that, let's see how we can sort it. So maybe what I'll do is ser2, I can just store the result over here and say ser2 dot sort, and it will take the sort level, and with the sort level I need to specify whether the level 1 or the level 2, so or the 0 or 1, because that's how the index sorts 0, let's say in this case, and execute that. And here we have now it's sorted by A. So for A 1 or 2, for B 1 or 2, for C 1 or 2. Similarly, if you specify 1, you will get 1 2 3 1 1 1 2 2 2. So whatever is the index at level 1 will going to be sorted based on that. Let's try now doing the summing of data. So for that, what we can do is go down and over here write the ser2 dot sum, and let's indicate the level maybe let's say level 0, and let's take output. So here we have for A 4 plus 1 5, for B it is 5 plus 2 7, and similarly for C you have 6 3 and 9. And like level 0, since you have two level 0 and level 1, you can have the sum by level 1 as well, so 1 and 2. So what is the total sum? 3 and 2 5 and 1 6. So for 1 the value is 6, for 2 it is 15. So that's about how you can you can basically do the sum for this series, or even if you want to do at a data frame level, you can do that. And you can see its additional properties by pressing Shift Tab. Again, access is equals to none. Skip any, whether you want to skip any or not, and you can actually expand its properties so that you can go down there and see its different properties and their explanations about what it is. So what we are using over here is simply the level parameter, but nothing else, because it's pretty basic and simple example just to understand how the sum basically work based on the different levels that we have in the series. And generally when you are applying the sum, this sometimes confuse, okay, why it has the level parameter and what is the applicability when it comes to doing the sum at a data frame level, because most of the time you just have in one level of index in your data frame and not at a multi-index or a hierarchical index. But in such cases where you have the hierarchical index which are related to each other, and you want to access the summing or maybe average or any other operation that you want to do, you can basically utilize the level parameter to go in and out into the hierarchy of an index. So that's about how you can perform some of the very common operations into the series. And that's pretty much all I have, and I'll meet you in the new video, the new topic. Hey guys, this is Abhishek, and with this video I am starting a series of Python data visualization. So as you are aware, or you must have seen, that visualization creates a lot of impact. So in the previous videos when I was explaining you about Pandas data analysis using the Pandas library, I have shown you how you can use the group by, pivot table and the other functions which are helpful in creating metrics and doing the analysis of data. But until unless you visualize it, it really can't give you that impact, because human eyes are really used to of looking at the visuals and then taking an impact compared to looking at metrics or the numbers. So with this video, as I mentioned, I'm starting it, and I am using the matplotlib library, which is a basic library, and the path is this: https://matplotlib.org, and within that the sub library is the pyplot API we will be using to basically plot the basic plots in the initial videos, and then in the future videos we will look at how we can import the data like a normal scenario. You need to get the data from an CSV file or from the database or anywhere else, and then you need to visualize and then slowly move on to the complex visualizations. Alright, so first of all I'm using, as you can see, Jupyter notebook, which is a part of Anaconda distribution. And if you are also using this, then you will be using the latest edition of Python along with pretty much all the libraries inclusive of matplotlib or pandas or numpy and everything. But for some reason, if you don't have this, and you can install the library by using the pip command by following this exclamation pip install and matplotlib. Since it is already installed, so there is no need to do the installation for me. So what I'll do is I'll just import this library, import matplotlib. After pressing the mat, I've just pressed the tab and I got these options that I have two libraries, math and matplotlib. So I will select the matplotlib and press enter. .pyplot. As you can see, I just wrote the py and press tab. it is giving me that it has three libraries: pyplot, pyparsing, and pylab. So what we need is pyplot. So I'll just enter this. So import matplotlib.pyplot as plt. So plt is a common kind of an acronym that used so that we don't have to write this entire name whenever we need to fetch any function like for example the plot. That's the one we will be using a lot in our videos to explain the different types of plots. So we will just say, hey, plot dot show, for example, or within the plt dot plot, and then providing the parameters. So that's about one thing. So with this library, that's the basic thing right now you need to do to start with it, and press shift enter. And when we press the shift enter, it creates the new line for us. Now let's create the a basic plot. So what we can do is we can simply write plt.plot and provide just one list to it. So maybe 1, 2, 3, and 4. That's it. Simply that piece, so that we will get to know what it is basically doing when it is getting these parameters. And if I press shift enter, it doesn't give you the output. Well, because after this you need to write one more function, which is plt.show. If I enter this, now the line is over here, and as you can see, 1, 2, 3, 4 is here on the y-axis. So 1, 2, 3, 4. So based on, so it has done some auto adjustment for writing these tick numbers y-axis, but it has automatically identified the x series or the x-axis values. How? Well, based on the series that it is seeing and its index value. So if you have seen my previous videos, whenever we are creating a series, by default it generates the index. So for this, for value 1, the index will be 0. For value 2, index will be 1. For value 3, index will be 2. And for value 4, index will be 3. So 0, 1, 2, 3. And same is the values over here, 0, 1, 2, 3. So that's a very basic and the default behavior whenever you are passing just the one argument. So let's say, for example, I'll just close this. So let's say, for example, you are passing one series and you are getting this visualization, the line chart, and you are not sure how the hell this matplotlib is picking up these numbers. So always keep in mind that these are the index numbers. Okay. All right. The next thing I want to show you is whenever we are writing or whenever we are creating a plot by using the plt.plot, we have to write plt.show again and again. But if you want to avoid that, there is a one argument that you can pass, which is %matplotlib inline. So what it's basically saying that, hey, don't use plt.show again and again, because I have already passed this magic command, the %matplotlib inline, and it dictates that all the charts, all the plots that you are creating will be shown inline irrespective of this plt.show command. So what I'll do is I will just execute this again by pressing shift enter. I will remove this, and now I will press shift enter again, and now as you can see, my line is displayed, and even I don't have the plt.show. So that's the more again useful, and we use it regularly in our examples or whenever we are doing data analysis, because writing additional command, every coder hates that. So we want to always optimize it, and this helps us optimizing the code. Okay, so that's the one thing. Now let's see. I'll just copy this and paste it over here, and I will just pass one more list to it. So 5, 6, 7, 8, maybe in this case, and press the shift enter to see what will happen. Alright, so now if you compare, if I just little bit go down so that you can easily see. Now if you compare, the y-axis values are now 5, 6, 7 and 8, and x-axis value is actually 1, 2, 3, 4. So it's starting with 1. Earlier it was 0 because we did not provide any values over there. So 1, 2, 3 and 4. So as you can understand from this is the x parameter, x-axis value, and this is the y-axis value. Okay, so this is about the very basics. But if you press within this plot function, if you press shift and 2 times tab, you will get this information about its various parameters. So for example, plot x and y using default line style and color, but it has other parameters. So if you are using that third argument bo within the single quotes, it will plot the x and y using blue circle markers. If you are just saying plot y using x as an index, like I mentioned earlier, if you are not having x value, it will use the x index. Similarly, if you have a plot comma y, the y value and the r plus, so it's basically the red pluses. So that's how you can modify it, but it has a lot of different properties. If you will go down and so for example, if you want to show the line style, so it's basically the style parameter for what type of style you really need. Similarly, character color, so if you want to have a line color, you just specify BGR to the color parameter. Similarly, if I go down, I will see a lot of different other properties like line width, for example, label, and all of those things. So let's experiment with a couple of few. Maybe for example, you want line width, and we want to specify line width, let's say 6, and press shift enter. Now you can see the width of the line have been impacted. So maybe if you have multiple lines and you want to show an impact with the help of the width of the line, you can change their parameter. Okay, similarly, I have shown you the color properties, and let's make it R, and now it is R. So you can change the color pretty much quickly. So these are like a few of the properties that you can get. Another, I'll just very quickly show you the line style property, because that's like a most useful one, because sometimes we have multiple lines and one of the line is the solid line like this, and couple of other lines are dashed line with different types of dashing. Some has lot of space between consecutive dashes, and some are having a different types, less or more. So the parameter name is ls, and it is, I believe, dashed, if I'm not wrong. Yeah. So if you see, with this dashed, it has changed to a dashed one. If you want to know more, again press shift tab within this function, and if you go down, you will see more like this. So dashed line style, dash dot, solid, dotted. When you specify dotted, this is how you will get. I have just specified the dashed, so I've got this one, as you can see it over here. So you have other ones like triangle down, up. So whatever is feasible to you and useful to you, you can change it and make an impactful line chart. So that's about it, the very basics of the line chart or the basic charts by just providing simple parameters. And I will meet you in the next video with bar chart, probably. Yeah. Hi there. In this video, I will talk about how you can create the bar chart. If you have seen my previous video, if I go up and show you, I have shown you the first video of matplotlib and introduce you to the basic plots using the plt.plot and all. So taking the second step and creating a bar chart, which is again a basic chart, gets created for pretty much every different kind of analysis that you are producing to see the sometimes the comparison among the different categories, or there is a stack bar chart to see the percentage difference between two categories, and sometimes group chart. So first of all, let's see how you can create a basic bar chart. So before I do that, we will import the library, which is matplotlib.pyplot splt, and I will use the percentage matplotlib inline. So as I suggested in my first video, matplotlib inline is helpful in cases where you don't want to use plt.show function again and again whenever you are creating a new plot, and this will help us creating the plot inline to our command. Okay, so I'm executing this. Now let's create two different lists. So maybe X to represent the x-axis, maybe 2, 3, 5, 6, 7, okay, 5 values, and the y is equals to maybe 10, 15, 20, 25, and 19 maybe. Press enter. Now you can create the bar chart with a very straightforward command, which is, I'll just delete this. Okay, so I just press DD, which is a shortcut to remove that extra indentation that was created. So to create a bar chart, plt.bar x, y, that's it, and you have the bar chart. Now as you can see, 2, 3, and it is seeing the values in the continuation and basically trying to see that whether value 4 there is a value or not. So either one thing that you can do is, maybe for this basic example, let's not go into the complexity and create a value which is 4. So 2, 3, 4, 5, 6, 7, and 10, 15, 25, 19. Add one more value, maybe 17, and create it. Alright, so here we have our very simple bar chart. Okay, now the next thing is, in a bar chart you always want to create some sort of label, so which is more or less like a label for this particular chart. So what we have is basically plt.title, our first bar chart, and that's how it will create the bar chart. Similarly, if you want to give the labels to the x and y, you will use the x label, and this is x labels text, simply because we are not showing. Similarly, and you have y label. So since we don't have a business context, we are using the arbitrary text values, y labels text. So here you have x label, y label. Similarly, if you see, you have a lot of different properties. Like if I start with the x, you have x label, x limit, x scale, x ticks. So we'll see as and when the need will arise to create the labels. But this is how for any chart, like previously we created the line chart, and you want the labels over here and here, you can easily create those labels, and with the help of the title you can create the title as well. Now let's say you have the requirement where you need to create the multiple bar chart related to this. So one thing is to create the dummy values. So maybe x2, and create the value maybe a similar 2, 3, 4, 5, 6, 7, and y2 is different values, maybe 15, 25, 19, 16, and 18. 1, 2, 3, 4, 5, 6, 1, 2, 3, 5, and 6. Alright, let's enter, and plt.bar x2, y2, and let's enter. So this is how you will get your bar chart, but as you can see, there is a problem, and the problem is that in some cases the blue is not getting a proper value. So for 5 the value is 25 for the y, and that's why it is coming over here. But here in case of y2, 1, so the 5 value is around 16, as you can see. So that's why you are able to see. So whenever the first y value is more than the second y value, you are able to see the chart. But if it is less than that, then you are not able. So here in this case it is 15. It has completely overlapped the first value, which is 10. Okay, so in my view there are two different ways by which you can overcome this issue. So the first thing is using the alpha value. So alpha is basically, the transparency. So completely the alpha is 1, so it's anywhere between 0 to 1, and if I specify alpha value as 0.5 and similar the alpha value as 0.5 and press enter, you will see the output little bit in a better context, right? And maybe what we can do is to get a proper representation, we can even get the legends. So our legend is not applied because labeled object is not found, as it is saying. So let's give it a label. First chart and label second chart. Let's see this. Okay, this gives some error. Let's quickly figure it out what it is. Unknown property LABLE. So I made a mistake while writing it. LABEL. Okay, so now we got it. So the first bar chart, the second bar chart, and wherever the grayer area over here or the darker area on the second bar chart indicates that it is the first bar chart. So that's one of the way by which you can overcome this issue. Another way you can overcome with this issue is using the width property. So let's say width and width, width, yeah, the spelling is, and right now the width is same. By default the width value is 0.8 as per the documentation. So I'll try and experiment it with. I'll make the first width value as 0.9 and the second width value as 0.7, and let's see what happens. Okay, now we get a better presentation. So alpha is removed, and clearly we are able to see that first chart is over here and second chart is over here. They are getting overlapped, but as you can see with the help of it, it's clearly representing that when the first chart is getting finished and whenever the second chart is surpassing, where it is surpassing. So I think this is a more cleaner way to represent similar types of problem if you are facing it, and get your presentation in a much better way. So the next piece or the next set of information I want to give you is about how you can resize your chart, because right now as you can see there are a lot of values and it's a bit squeezed up here in this space of bar chart, the boundaries. So what you can do is you have something called plt.figure, and within that you can give the fixed size, and this is a tuple. So we specify, let's say 10, 5 in this case, and press shift enter, and as you can see this is a bit good. Maybe we can do 15, let's say, much better. Okay, so that's about how you can change the figure size, how you can use the alpha or the width property, depends on what makes sense in your case, and get the output. Okay, so that's about your first bar chart. I think we made a pretty good success with how we can make it impactful. And I will meet you in a new video with some new type of bar chart. Hi guys, in this video I will talk about the histograms. So in my previous video I have talked about how you can create a bar chart like this within the Python matplotlib library. And the basic difference that we have between the a bar chart and the histogram is basically histogram is useful for looking at the distribution of data. So what happens is on the x-axis you have the x-axis value. It can be, let's say, your age, your height or anything, and then these bars basically or always represent the count. So this way we identify whether in a particular nation, there are people who are like of less height, or there are people who are more height, or if it is like this, then we say, okay, that's okay, that there is a proper distribution. There are good number of people on higher side, lower side, as well as on the middle side. So it's kind of a normal distribution that it follows. So that's basically the differences between a bar chart, usage of bar chart, and between the uses of bar chart and histogram. So I will go to my code over here and import the library, import matplotlib as .pyplot as plt and percentage matplotlib inline, so that I am getting my charts in line to my code. Otherwise, if I don't write this line, as I mentioned in my previous videos, I will have to write plt.show to view my charts. But with the help of this magic command, I don't have to write that particular line of command. So shift enter to execute that. Let's create maybe value 1. It can be anything. I mean, let's say it is the height, and generally NP, the height is between anywhere between, I would say on an average it is between 150 centimeter to 200, let's say, for example. So what we can do is we can actually get the numpy also to basically get the ranges. Import n numpy as np. So first what we can do is we can use np.arrange. I think I executed this. Ideally it should come if I'm np.arrange, yeah. And then the first of all the start value 150, the end value let's say 200, and the step maybe let's say with every 2 values. And so this is the data that has been created for us, and let's see, it should be fairly straightforward but while plotting it, but that's basically represents, let's say, the height of probably man, let's say, for example. So what we can do is we can not shade hist and height. Alright, here we have the height starting from 150 going up to 200, showing the distribution which is relatively flat. What we can do to make it more meaningful, since it is right now having no width or no space between the bar, we can use the r width parameter, which is a row width parameter, and say let's 0.9, and here we have a proper row width. Now after that we can also have the distribution, let's say between 150 to 170 there is 1, and 170 to maybe 190, or then rest of them 200. So maybe like 3 bins. If you want, we can just specify the bins over here. So let's say 3. Now we have 3 bins. If I want 4, I can get 4. And that's usually, people really experiment with the bins about how many bins that they have. Generally, when you are creating the bar chart, the histogram first time, you are not aware how many bins you really need. So people usually experiment with this. Also, you have the options where you can have the bin specified let's say 150, and then next I want 165, then next I want maybe 175, and maybe 190, and then finally 200. And now here I can specify the bin and press shift enter. So now as you can see, I have two bins which is kind of clubbed over here, and I think two bins clubbed over here. So but it has basically, you know, segregated the data into multiple bins for me. As I can see, 165 is coming over here, then 170, and then here 185, and then finally 190, and then finally it is going to 200. Now after creating these bins, you have some other properties also which are very useful, like let's say if you have multiple histogram over here. So if I go ahead and show you, so we have this height, let's say we give it height underscore m to say male height, and height underscore f, and let's use the random this time, dot rand number, and let's give it like maybe 20 random numbers. So it can be any random number, so let's just give it a name value because that will not representation of right height, but let's keep it as height just to. So executed this plt.hist, and we have height, and now within the brackets we can specify these two values, and let's have the bins automatically been identified. So now it's little difficult for you to see, so what I can do is I can simply follow this which I was following. I was thinking that I will show you both the effects, random number and all. So maybe let's say in case of female, generally, you know, here in India I would say the height is a bit less, so I will just go and say maybe 140 to 180, and give it different names to these, underscore m underscore f, execute that, height, give it a name, height underscore m, height underscore f. Alright, so now we have the two different heights, and for females, as you can see, it's going over here. Right now we are not able to see the legend, so let's go ahead and see plt.legend. Okay, I need to give the label over here, that's why it is not giving the, so male, female. Alright, now we have the label male and female over here with the help of the legend and the label argument. But if you will see the real life, like for example I've shown you this one, it shows proper, you know, random distribution. So how you can basically experiment or create a random distribution, it's basically by rand underscore n, random n, the one which I showed you earlier, random dot rand n, random number. So to generate, let's say 1000 random number we want to generate, and then create a histogram, plt.hist, and say rand underscore n. Okay, now you see it's pretty much a similar structure like this. And generally when doing regression, you know, that's like one of the normal assumption that the data should be normally distributed, and a normally distributed data looks like this. What I can do is I can use the r is equals to 0.9 for a better representation. So it shows that similar sort of bar on both sides with the same, you know, count. That's why we are saying that it follows a very close random number distribution. Another property, or rest of the other property, if you want to see, you can press shift tab, and we have his type is equals to bar, and whether it's a stack bar chart, and orientation is another interesting one. So maybe we just showed you orientation is it's basically vertical. So this is a vertical. What you can have is a horizontal also. So horizontal, maybe let me just check. Yeah, small. Okay, so here we have the horizontal one. So sometimes there is a need that you want a horizontal distribution, and you can do this. Use this property. But there are rest other very interesting properties which you can use, like weights, cumulative, all of that one, and down there they have shown you the description as well. Like for orientation, I use the horizontal, and by default it is vertical. So this is about how you can create the histogram within the matplotlib Python library. So that's pretty much all I have, and I'll meet you in the new video, the new topic. Hi there, in this video I will talk about the scatter chart. So scatter chart, as you can see it right over here, it's very useful for visualizing a lot of data points. Let's say if you have, so for example on x-axis, let's say you have discount values, and on x-axis you have discount values, on y-axis you have, let's say, sales values, and probably you want to see that when your sales is high, then whether there is a high discount or not, or if the sales is less, even after that you are giving a high discount or not by maybe your sales rep or channel partner, things like that. So to see those kind of relationships over thousands of or hundreds of thousands of data points, I have seen that scatter plot have been really useful to visualize that data over the two numeric dimensions. So I will show you here in this video how you can create a scatter chart within the Python's matplotlib library. Alright, so let's go ahead and come to this scatter plot. So first of all, as usual, we will import the matplotlib.pyplot library as plt, and we will use this matplotlib inline magic command so that we don't have to write plt.show again and again, as I explained in my first video. So after this, let's create two values. First is x for the x-axis, maybe 1, 3, 5, 7, 9, 11 and 13. As you can see, there is a difference of 2 between each value. And the y value, let's say there is 25, 35, 21, 67, 63 and maybe 55. Yeah, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 and 7. So let's give it one more value. Though when you are using the real time, you can simply use the column names, and I'll show you that in this with the help of a real-time data once you get some basic understanding. So I have executed this, and now I want plt.scatter, and simply I'm passing x and y, and here I have my data points. So as you can see, on y-axis is going from 20 to 60, as we have 25 to almost 67 and 30. It's going up till here and showing you when they are crossing. So first value is 25, so over here 1, 25, then you have 3, 35, so like over 3, 35. This way you can get an idea how your values are over the two numeric dimensions. Now couple of parameters that definitely you can adjust to make it more meaningful. So I'll just show you a couple of them and then followed by some practical example. So let me show you property which is x comma y, and then you can specify the marker over here. So the property which is marker, and let's say I want x as a marker, so I can get x as a marker, and you have a lot of different, you know, the values for the marker. Like by default it is O, but you can use this, you know, command to get tilde and matplotlib.markers to get the more number of markers. But down there we should have, I think, some information, but no, I think in some different case I have seen that. So you have X, even you have star if you want. So all these ones, these are helpful in scenarios like you have multiple, you know, values over here for multiple dimensions. So for example, right now this is X and Y. Let's say we have X1 and Y1, and maybe X2 is again 1, let's say 3, 5, 7, 9, 11 and 13, and Y2 is equals to your any random values like 30, 24, 65, 45, 39, 55, 2, 3, 4, 5, 6, and I think there are 7 values, 1, 2, 3, 4, 5, 6, 7. So let's give one more value as 21, and then down there we can specify here, and then here let's give it X1, X2 and Y1, Y2. We need to specify the color properties to get the segregation, and let's say R and B, and then enter. Okay, we missed something. Watch. Okay, yeah. X1 is not defined. Probably I may have not executed it. So X1, Y1, X2, Y2, X1, X2, Y1, Y2. Good. Okay, now it's working fine. And as you can see, with the help of marker and color, we are able to, you know, get the differentiation between the two different data points. Another interesting property is about the size, and it's straightforward, and say S is equals to just 100, and it will give you the output. So like I suggested, you can always press Shift tab, because if I correct pretty much everything like alpha, which I covered it earlier, CMap, edge colors, these are like a lot of different properties with which you can explore. Now let me show you how you can get the data directly from a file. So for that I will use import pandas spt, and I will create a new object which is orders is equals, and I will say pt.read underscore csv and specify the path over here. So the path is this, and we are getting the first sheet, which is order sheet. So I'll press execute it, and it has given me error. Let's see what it is. Check of int has no lan. Ideally it should not give me any error. So okay, so now what problem is that this is an Excel file and I'm using CSV. I'll just use the read underscore Excel. So now it's fine. If I show you the first two observations, these are the observation like a real-time data set that you will usually get. So we have the sales and discount, and let's try to create the sales and discount. So for that, what I'll do is simply plt.scatter, and here I will pass orders.sales and orders.discount and shift enter, and here I have in just a few seconds my chart, and as you can show you on the y-axis you have the discount, since we have discount over here. So you have the discount on y-axis and you have sales over here. So here the sales is high, even after that we have given the less discount, but here sales is low, but in many cases we are giving the high discount. And here are most of the observations where a general or a normal discount has been given. So always an interest area is equations like data points like this or this or this, which are a little bit like an outlier. Here in this chart, one interesting thing that we can probably try is the profit. So based on the profit, we want to change the size of the circle. Let's see what happens if I give the S parameters to profit, and let's try to execute. Okay, not pretty good, because for some of the values the profits is really high, so they have been increased like hell, as you can see. Well, so probably not a good parameter, but as you can see, it can work if we have relatively good values as compared to the one which I have it over here. So that is a parameter that you can specify. Let's probably try it with the maybe unit price. So unit price has a space, so I will have to write unit price like this. And with the unit price also, I think there is a good unit price for some of the value, some of the orders. So over here showing the less unit price, and this is like a big unit price. So with this you can change or do the variation into your chart and make it more useful. So that's pretty much all I have for you in this video, and I'll meet you in the new video, the new topic. Hi there. In this video I will talk about Python's matplotlib's stack chart, or the area chart. If you have used it in Excel, you must have seen it under the name area chart. So this chart is sometimes very helpful in viewing the distribution like this, where the values, for example, in case here in blue it is increasing, but here in case of orange it is decreasing. So they are stacked upon each other, and then finally you have the gray value, which is stacked on both blue and orange. So how you can create a similar type of chart in the Python using the matplotlib library, I'll just walk you through. So here we have the Jupyter notebook, and I will just import the matplotlib.pyplot library as plt, and I will ask that matplotlib inline, so that I don't have to write the matplotlib's plt.show method to view the chart. This will help me to view the chart as soon as I'm executing the command. Alright, so here we have both the libraries imported, and since this is a stack chart, we need to have one x-axis, so maybe x, and or I will just give you some context. So for example, let's say you are a manager of a processing center where the shifts are going on, and maybe let's say there are 3 shifts which are going on, and you have the data for these shifts for 5 weeks, and trying to evaluate how the things are happening in the different shifts, so whether there is an increase, decrease, or how it is. So let's say we have week and 1, 2, 3, 4 and 5 weeks data, and maybe for shift 1 we have let's say 40 hours, then 35 hours, then 26 hours, then 20, let's say 3 hours, and finally 20 hours. Shift 2, let's say you have 40 hours, then 32, then again 40, then maybe 45 and 50, and in shift 3 it's pretty normal, 40, 35, 45, and then 42 and 40. Okay, so we now have this data, and now let's create a scatter. So what we need to give is week and shift 1, shift 2, shift 3, press enter. Why I used scatter, I don't know. I should have used the stack. Okay, plt.stack plot, and then week, shift 1, shift 2, shift 3, and here I have the information. So it's clearly, indicative that for shift 1 it's not performing well. Maybe there is a lower volume, but as you can see, for shift 2 the volume is going high. Maybe these guys are not working properly over here, so that's why it's the volume is shifting over here. But these guys looks pretty okay. They are pretty consistent with their approach in terms of the number of hours that they are spending. But one thing that becomes quite confusing is about what shift it is. So what you can do is add a label and say shift 1, then shift 2, and then shift 3. Alright, the label we need to call the legend as well, I guess. Still a problem. Okay, now let's see why. Fill between got multiple value, argument label. Let's see what it is, whether it's a label issue or what. So it's think labels. If I press shift tab and I will labels, a list or tuple of labels. So we have provided a list, and here we are. So now I can clearly see which is shift 1, shift 2, and shift 3. So that's a very basic nature about or a basic way of creating the area chart and trying to understand with the help of these shifts how these data points will reveal the information from the data. As always, my suggestion, you can always go to here and press shift tab and review the the arguments based on the further enhancement you want to do. So for example, baseline, it has multiple argument, and similarly labels that we have used, we have colors as always, and finally shows how you can get the information about the collection for each of the class element in the stack area plot. So this is the command that you can give directly and get the idea if you are really want to go much more deep in that. So that's pretty much all I have for you in this video, and I'll meet you in the new video, new topic. Hi there. In this video I will talk about a practical example where you can use the data visualization, and generally the practical examples or the practical scenarios are different from what you really learn from theory or from tutorials. So far I've shown you some of the basic examples about how you can use the matplotlib library, but in this example my motive is to give you a little bit flair or a taste of how the real world situation looks like, and then how we proceed ahead with the visualization. So first of all, let's import the libraries, which are, let's say, first of all, Pandas. Just remove that. Import Pandas as PD, and numpy. Probably we'll need numpy to create an array of a range. I'll tell you why. And then import matplotlib.pyplot as plt, and then to produce the chart we are saying in %matplotlib inline. Okay, quite a fast way we have imported pretty much the basic library, but if we need anything else in terms of libraries, we will see it during the example. And I want to show you this example by utilizing the file that I have been used since my Pandas series, where I have shown you this sample superstore sales example, and we are getting the first sheet by indicating 0 as the parameter for this function pd.read_excel, which contains the orders data. So if I go ahead and view the first two rows, here I have orders. Okay, so it's pretty straightforward. You have a lot of columns like order ID, order date, priority, order quantity, shipping mode, and all of that thing. Now let's say based on the dimension you have, that really basically trigger the analytics. For example, based on the order priority, whether your sales is really high in a particular type of order priority, or your sales is high or low on a particular type of sales, on a particular type of ship mode, maybe province, region, who knows, right? That's kind of a job of a data researcher or data scientist to look at really all the angles, do the comparative analysis, and then figure it out and show the observations back to the user or the management who is really interested in knowing what's actually happening, what is impacting our sales. So in this video, what I'll do is, looking at the shipping mode, we will try to segregate the three different shipping modes. So if I'm not wrong, you have regular air, delivery truck, and I think there is one more. So if I want to see the shipping modes that are available, then what I can do is I can say orders ship mode dot values dot unique. If I'm not wrong, it should show me the value. Does not have any value as unique, so what I'll do is value underscore count. That will again give me the values. So pretty straightforward. You have regular air, delivery truck, and express air. These are the three values, and regular air is definitely having the most values. The count is highest, followed by delivery truck and express air. So that basically gives you, first of all, an initial idea. Okay, in your company, your regular air delivery mode or the shipping mode has been used frequently, and that may spark some question in terms of, let's say, spending, where your spending is happening more, whether in a delivery truck or a regular air or express air. So you can actually trigger those type of questions. So but here we are interested in sales, so let's move ahead and see it. So we will create three different series objects to visualize the three different data set over each other. So on top of regular air, we will visualize the delivery truck and then the express air. But there are some issues, and let's see those issues. So first thing is, let's create three different orders underscore RA, so which indicates regular air, and that is how we can do is, within the orders, and again the brackets, ship mode equals to and then regular air, and after this we want what column we want. So from here, if we want profit, we need to specify the dot notation and say profit. If you want sales, we can get sales. So what it is doing is nothing but filtering the data within the orders for regular air, and we want sales. Alright, let's see a couple of orders. .head. Okay, so here we are. So as you can see, for 0 index you have value, for 2 index 3, 4, 5, and if you want to shape, orders underscore RA dot shape, well, 6270 observations, and as you can see 6270, but it has a hidden issue as I have been talking about. So I will show you in a couple of minutes. First of all, let me just for delivery truck and express air create the value these subset. I'll just do the copy, Control C over here. Now for delivery truck, what I can do is specify DT, again paste, and what I can do is specify EA. Alright, and I don't have to do a lot of writing, I hate that, so I'll just copy. Ship mode is this, ship mode is express air. So this way now I have 3 different objects, right? So if I go ahead and execute this, there are no issues. And again, I want to show you orders underscore RA. Again, we will look at the shape 6270 and dt dot shape. So there is 1146 and 1146, so that's good. There is no issue in our filtering. And EA dot shape, and there is 983. So we are good. There is no issue in the filtering that we have done because it is coming as per the value count from the original data sets based on this function that we used. Alright, now let's go ahead and plot the values. So plt dot plot, and we want to plot, let's say the last one we chose is orders underscore EA. And let's say we want to red plus sign, so R plus, press shift enter, just given me the value, data frame has no object as okay underscore. Alright, so here we have the values, and as you can see it is going up till here 8,000 and the value is going up till here till 25,000. So this is fine, but why x-axis is coming 8,000? But so if you remember from one of my very initial video related to matplotlib, is if we are just specifying the one single object or one single series object, it takes its index values over here as the x-axis. So what I meant by that is, if I show you orders underscore EA dot head and let's say 10 observations, so what it is doing is, this is the value of index, this is the actual values, so this index value is coming over here and these values are coming over here on the y-axis. Now if I look at the shape of orders.ea, there are just 983 observations. So ideally this should be 983 but not the 8,000. So these kind of issues or misrepresentation you can have whenever you are starting with the data visualization. Those who are experienced probably are aware about it and can fix this problem, but those who are new, they basically come into this trap where they just try to plot. So for example, we have just plot the EA, then another plot that we can do is with the orders underscore, let's say RA, and we want blue plus sign. So here we are, blue plus sign and red plus sign, both the values are coming up till 8,000. And even if we want, we can plot the third one, which is orders underscore RA underscore and then C plus, this is cyan. So here we have the 3 values, but now the issue is that you can't see the blue one pretty effectively, the plus red sign and all, because most of these values have been overlapped by the third observation. So what you can do is you can use the alpha property and make it like 0.3, which will make it transparent a lot so you can see these observations. Okay, not that much great, but if you increase the figure size you will get to know, but at least it will give you an idea. Okay, there are some few observations of negative and the blue or red or cyan. So that's basically not what I wanted to explain. That's basically to show you how you can see the overlapping values, but the real issue is how you can get the data into the right shape so that your observations are not going up till 8000 because of the index issue. So how we can remove that? Well, I'm leaving this video here so that you can do some thinking and do an experiment about what you will really do in this situation, and in the next video I will show you the solution. Hi there. So in the previous video we have talked about the issue related to the chart that we had created. So we have created a chart like this where we wanted to see the sales by different shipping modes. So we created the different objects like orders underscore RA for a regular air sales, and then DT for delivery truck sales, and EA for all those shipping mode for sales which have been done by express air. And then we plotted this, and this is what we got. And the issue was that this ordered underscore EA dot shape, so by express air, it has only 983 rows. If you see it by red R plus, that's what we have indicated over here. And if you see the observations, it is going up till this 6000 mark or even 8000 mark. Well, I left that video at this point, and so that you can think through and figure it out why there is such an issue. So the issue is because of the indexing. So what it has is, if I just show you orders underscore EA, and this value is starting from 8, then 21, then 47. All of these values are basically getting plotted on the x-axis, and if I go down, you will see that x-axis values are spread across 8398 even after you just have the total number of rows is 983. So to resolve this kind of an issue so that there is not a wrong representation of values on the chart, what you can do is re-index the chart. So for that, first of all, what we need to do is create an index. So maybe what we can do is order underscore EA underscore index, and then use the np.arrange, and in that we will start from 0 to 983, 1. So if I just plot it under orders underscore EA underscore index, you will see the index value is starting from 0 and going up till 982. And let me see how many. I think it was 983 that we had. Okay, so we are good with this because the total values that you have is 983. And now what we can do is for orders underscore EA index, we can specify this value. So now orders underscore EA dot index is equals to orders underscore EA underscore index. And now let's see the orders underscore EA. Okay, underscore. So now you can see my values are starting from 0, 1, 2, 3, right, and going up till 982. So now my issue is resolved from the x-axis perspective. And now if I go ahead and plot it again, let's say this is a 1 which I wanted to plot, go down and paste it here, and now you will see my values axis is correct from 0 to somewhere 863 or 862. So this is how you can resolve the issue. And for rest of the other two objects, right, if I just go up and show you that, it's become a little big output, so taking a little bit of time. So orders underscore EA, similarly you have orders underscore DT where you have 1146 values, and then I think there is one more, so express air, regular air, RA in that case, so you can change it to RA. So for this you can create this range from 0 to 1146 and then assign it, and for RA you can again create it up till 6270 because it has the maximum values, and this way you will get to know the right x-axis, the right distribution, as well as right plotting of values on the y-axis. So this is what I mainly wanted to cover in this solution video, and I've already shown you how you can resolve one, and I am leaving the rest too so that you can do an exercise and get familiarity. So that's pretty much all I have, and I'll meet you in the new video, the new topic. Hi there, this is Abhishek, and in this video I will talk about the scatter plot matrix that you can create with the help of the Pandas library. So as you can see, I am showing you here right now the scatter plot matrix. So on the x-axis, if you see, there is sales, discount, profit, all of those different numerical variables. The same numerical variables you will see here on the y-axis. And the benefit is that in just one simple graph you are able to see the overview of how your different variables are correlated with each other. So for example, in case of, let's say, this showing a linear relationship, so as you know, the sales and the profit is showing the linear relationship, they are going high. When the profit is increasing, the sales is also increasing. So, or vice versa, you can say that sales is increasing and profit is also increasing, and basically try to see whether any correlation exists or not. So for example, in case of unit price and in case of discount, doesn't seems to be a correlation. Similarly, in case of profit and discount, similarly in case of this unit profit, unit price and discount, like shipping cost and discount, doesn't seems to be a visible linear relationship. Same is the case if you see the histograms. These are all the histograms which are diagonally presented for this matrix. Doesn't show that there is normal distribution, but they are skewed either to the mostly towards the left side. So how we can basically go ahead and create it within the Python notebook, I'll just show you in a few minutes. Okay, so here we are on a scatter plot matrix. So if I just come here and get import pandas as PD, and to get the plot in line, I will just use percentage matplotlib inline. So pandas is spelling. Okay, after that let's get our data set. So here we are with our data set, which what we are seeing is with the help of pandas library PD, which is here, read.xl. This is the path of the file that we need to access, and 0 is basically indicating that we want to access the first sheet, which is the orders sheet, and then we are storing all of this data here in the orders object. Alright, after that let me show you the first couple of observations, maybe just two. Yeah, so here we have the sales, the discount, profit, unit price, all of those values. So if I show you all the columns, I can use orders.columns, and here all the columns are over here, and if I want to know how many total rows and columns which are present, then I can use the shape. So we know that now 8399 rows are present and 21 columns. If I want more information about these different columns, then I can use info function, which will give me that for row ID how many rows are there, whether it's a null or a non-null, and then what is the whether it is a float, integer, date, time, what it is. So some useful functions you will always use in every analysis, just to get the idea about your data set. Okay, now let's come to the business with the scatter plot metric. So the first thing is saying pd dot scatter underscore metrics, and within that, if I show you some of the columns that we need to fill. So for example, we need to say frame, alpha, figure size, and different parameters, grid, diagonal, by default histogram. All of those options are default present. So let's go ahead and try to create the histogram, the scatter matrix with the default parameters. So what we will do in this case is we will write orders dot loc, or maybe loc is good, fine. And we want all the rows, and then we want columns from let's say over here we have sales, discount, then profit, then unit price, and shipping cost. So let's go ahead and write sales colon and then shipping cost, covering all of the. So what it does basically, this scatter matrix just picks up all the numerical columns which are there. It will not pick the ship mode which is coming in between of the discount and profit, and will just show sales, discount, profit, unit price, and shipping cost. Even after that, if you would have any variable over here after a couple of object variable which contains the textual data, it would have skipped that and gave us back the numerical columns. Alright, so this is about the basic information that you need to provide. So let me hit shift enter and let's see what it produces. Okay, alright, here. So here we are with this plot, and here we have our scatter plot. Now the issue is that this plot is not properly sized. So what we can do is we can go back again up there, and one of the parameters I show you after comma, I'm pressing shift tab, and the fixed size, I'm using the fixed size to change the size of this figure, and maybe I want, let's say 12,10, and now let me press again shift enter, and now let's see how it is coming. So if I go down, okay, now it's coming a bit better. If I just remove the header, yeah, now all of my columns are coming. So with that, you can basically experiment fixed size parameter, that what is the figure size that you need. Okay, so 1210, maybe you just want 6,10 or 10,6, depends on your requirement. You can play around and get it done. Let's see another parameter which is very interesting. Right now, if you see for this diagonal representation, we have the histogram, but there is a option which you can change to a more visually aesthetic the diagram, which is KDE, kernel density estimation. So let's go ahead and see that. So I'll just copy the previous code so that I don't have to write it again, or maybe here itself I can change. Now if I say diagonal, by default, if I show you by pressing shift tab, this parameter diagonal is basically histogram. So you can change it to KDE. Let's shift enter. It will take a couple of seconds. Now it is there, and here now you have the KDE, which shows much better information as compared to the histogram about the distribution of data. It's clearly saying that here is a peak, and then we are seeing that when the values are starting, they are at top, but right on this point it is going up to the down. So that basically give us an indication that what's really going on with the data. So for example, here it's a weird chart, and over here it's going up and then finally going down. What's really going on here? Is there any pattern that it is revealing, or any information inside the data that you are about to explore, or you should explore? So that's how you can change the KDE. Apart from that, it has, as you must have seen, if I'm going here, I'm pressing Shift Tab. Again, it has like marker, basic one, alpha, very basic one, density KWS, hist KWS, range pairing, all of those different parameters that you have, and you can actually go to the documentation of this scattered matrix if you really want to go deep down and try to understand all of these parameters, which basically you can utilize to create an impressive and better scatter matrix. But the idea was that I'm giving you the quick overview of scatter matrix about how you can use it, but I find it very useful. I always create this metric whenever I'm doing any data analysis or any data science project. So that's pretty much about it, and I'll meet you in the new video, the new topic.
Hi there. In this video, I will going to cover some of the box plot chart features and basically show you how you can create the box plot directly from data frame. So in this video, I will cover most of the basics, and I have the second video in which I will go a little bit in depth to look at how you can get the real interpretations back from the box plot chart. Alright, so let's go ahead and first of all see how you can plot it using the data set. So first of all, I will going to import Pandas library. I will import the matplotlib.pyplot as plt as usual, and to plot the chart in line, I will use %matplotlib inline. Alright, inline. So here we are with these three commands. Now let's go ahead and get the data set. So this is the data set we have been using, orders data set from the Superstore sales file, and we are fetching the first sheet, and let's go ahead and get it. Okay, now to plot a box plot you need a numeric column, so let's go ahead and see the orders dot columns, and here we are with row order ID, order date, order priority, again not a numeric one, but order quantity is basically something which is numeric. Sales is for sure numeric, discount is numeric, profit is numeric, same is unit price, shipping cost. So these all looks like all the numeric columns. So to plot the box plot, what I can use is plt.boxplot and then specify the column name orders dots. Let's say first of all I want sales, and if I press Shift Enter, here I have with the orders data. So this is basically I would say very skewed the data over here, because there are a lot of outliers. The boundaries of a box plot are really squeezed. So let me try and show you the different one, maybe discount for example. Yeah, so it shows a good representation, at least for this example, to get you an idea about how you should really see and know about the box plot. So what it is basically showing you this is basically a median line where you can say average discount is somewhere around 5% for all of the products across the company that you can say. And here are some of the outliers, and then you have the upper boundaries. So this is basically represents the 75. So this is what they say is interquartile range, and this is the upper and lower boundaries,
and there are certain data points which are even going beyond the upper and lower boundaries, and we call them outliers. So this is very helpful in those cases also where you want to know about the outliers, or you want to do some analysis, and to move ahead with your analysis, you really need to know what the outliers are, because they drastically change the expected result, and you are kind of not expecting this. So for example, you are in an organization like this where sales are happening, and you got that one very big customer who is purchasing product worth, let's say, 1 million. However, your average sales is somewhere around $100,000 in a month. So think about this, how much your data will be skewed, because whereas your $100,000 and one is, on the other hand, you have $1 million. So that will show that in rest of the quarters or in rest of the months, your company is really performing poor, and in just 1 month it has exceeded all of these expectations of the management. But that's not right? You need to remove that particular data set or the value from the data set, and then do the analysis, because that's an outlier. Everybody is aware about it. Okay, so that's quickly about the outlier analysis that you can do with the help of for the box plot. But like I showed, I just changed the variable over here, and that's a very simple representation. If I want, I can say even profit. So profit is also, as you can see, there are a lot of outliers, and the boundaries are really less, they are squeezed up. So you can have this kind of data set. They sometimes exhibit a lot of good information when you further interrogate it, let's say by different dimensions, and that's what I will going to cover in the next video. So maybe, for example, across the company, this looks really squeezed up data from the box plot perspective, but when you divide this data into dimension, let's say shipping mode, maybe let's say product category, you will get to know more about your data set, that why it happens in which particular category, and that's what your entire data analysis is. So that's the column. Another column we have is order quantity. So whenever you have space, what you can do is you can just specify these brackets, and within that specify order quantity. Okay, so here we have the order quantity, and as you can see, it's a very nice, there are no outliers. This is very well distributed. You can see 75% of the values are coming anywhere between 10 to 40, and the rest of the others are basically coming until the 50 as a quantity, and starting with somewhere around 2 or 3. So on an average, you can see you are selling somewhere around 27 or 28 is your median. Now along with the median, you will always want to see what is my mean value. So if you are not aware what is the difference between mean and median, I will just suggest do a Google and figure it out. So what I will say is, so here is a mean line. I would just say mean line, and if I press Shift Tab, it will show you all of the parameters that we can. So for example, I am showing you the mean line, and we get it back. So mean line is here, mean line is none. So let's go ahead and change it to true, and let's see it. Okay, I think the mean line and median line is overlapping each other, and that's why you are probably not able to see it. But there is another property which is show means, and now as you can see, it is showing you an indication. So my understanding was right. Its mean was equal to median, and that's why it was not showing you the mean line. But here in this case, you can clearly see where your mean is. It's right there on the median line. So that's one thing. The next thing is changing the way about how it has been shown over here. So right now it is vertical, and we have this property vert is equals to, by default it is true, and if I change it to false, you will get the horizontal one. And that's very useful in some cases where your data is in such a way that you want to plot it like this, the horizontal, the one plot, the second, the third, the fourth, and the fifth, and then you want to do the comparison, because sometimes for your eyes that gives you a better interpretation, better understanding of the data. So if you want that, you can change it to false. Okay, what I'll do is I'll just copy this and move it to next, so that I am not making it as a very busy one. So I am pretty much done with this, and I'll just come to discount. Okay, so here we have again back to discount, and couple of things like for this 0 0, sometimes you have a, let's say, requirement that you want to change this 0 to something else. So what you can do is, maybe let's say you want to indicate plus signs. So C is basically cyan, and if I am alright, let me say SYM is equals to, yeah, now it is fine. So you can actually look into the documentation about all the different symbols. This is C. Again, you can have B also, that will basically the blue one. So wherever it is making sense for you, you can simply change it as per the way you need it. There is another very interesting way to see the confidence interval of your median. So what you do is, there is a property, if I press Shift Tab, and this is notch. So if I say notch is equals to 1, which is a second parameter in this case, so here you will say the diagram has changed, and though you may not be able to see it completely, but what it has done is plotted the confidence interval. So if you are really interested in the confidence interval related analysis, you can specify this notch parameter as 1. So if I again show you, this is the first parameter, this is the second parameter. By default it is none, but you can change it to 1. If you change it to 0, it will not show you the notch or the confidence interval separation that is related to the median. Last but not the least, that if you want to remove all of these outliers, in some of the cases like profit you had seen, or in the sales you had seen, there was so many outliers. So sometimes you just want to remove it, just for the sake of you really want to understand what is going on with my main data. So here if I press Shift Tab again, so this is X notch, and then there is a parameter that you can specify that will actually going to remove the outliers as well. Oops. And that is nothing but your symbol. So if your symbol, let's say you are saying none, if you're removing this, you will remove your outliers in that case, and you are clearly able to see how's your discounting, or how is your discount is on the normal data as compared to your without your outliers. If you want to go back with the outliers, red plus, so here you are with the red plus. So that's how you can really do the pattern analysis, remove the outliers, and look at your entire data. So that's pretty much all I have for you in this video, the basics, because it's important to understand how these different things works in tandem. And in the next video I will further grill the data to show you the box plots by different dimensions, and with some more parameters that make sense for the data analysis. So that's pretty much all I have, and I'll meet you in the new video with a new topic. Hi there, this is Abhishek, and in this video I will show you a different way about how you show your plots. So far in my videos, if you have seen, as well as other tutorials, you might have seen that we have been using percentage matplotlib inline as one of the ways to show the plots inline to your command. So that really helps in terms of viewing the plot. But what if you want to make it more interactive, things like you may want to zoom it or do the selection on the chart? Well, in that case, you just need to basically change this inline to something called notebook. That's it. So once you change it to a notebook, what it does is basically it converts a normal chart, a static chart, into an interactive chart. So let's see it in action. So here we have percentage matplotlib notebook, and let's go ahead and import matplotlib.pyplot as plt like always. Let's specify x value, maybe some random value, right, and some random value for y, 17. Simply say plt.plot, say x comma y, and plt.show, and here we are. Well, here is our chart, a simple line chart based on some random values, and if you see, it has this stop interaction button. That way you can stop the interaction, but if you go down a little bit, you will find a couple of icons like home, back, forward, and then pan axis, like it is indicating it over on the right side, that pan axis with left mouse, zoom with right, and then you have zoom and save to download the plot. So what it is basically, if I go and click on the zoom, I get this cursor with plus sign now, and I can zoom it only this part. So now this part is zoomed, and if I want, I can use this pan axis icon and I can change it, and I can move up, down, left and right to view the desired data. This is really helpful in cases like scatter chart, where you are producing or you are showing a lot of data points on the chart, and you want to zoom it on a particular section, and then use the this pan option to basically move up, down, left or right on the chart to better analyze it. Once you are done with it, you can come to home to basically come back to your original chart, as well as based on whatever interaction you have done with the help of zoom and this pan button, you can use back and forward based on those actions and see what you had done earlier, or you want to move forward, then you can move forward also. So that's about how you can make your chart interactive, and hope this tip is useful for you. Hey guys, this is Abhishek, and in this video I will give you a quick trick about removing this text which is coming when you are showing the matplotlib chart. So it comes because we are using %matplot inline, and it gives us some useful information, but sometimes like in this case, it's really irritating because it is taking a lot of space, which ideally should be for the chart. So idea is that if we want to remove this, here let's say in this case, this is all the text which has come, and for this second chart this text is coming. So if you want to remove this, there is a quick trick which you can apply, and that is like just pasting a semicolon after this command, and if I press shift enter now, you will see that entire text is gone. Alright, if I press semicolon, again my entire text is gone. So that's the quick trick I wanted to give you about removing that text, because I found it really irritating, and I just did a little bit of research and found this cool trick, so just thought of sharing with you. Hope you liked it. Hey guys, this is Abhishek, and in this video I will talk about how you can adjust the limits, add the label names and grids to your matplotlib chart. So let's get started. First of all, I will just show you about how you can prepare your data from your existing file, which you will usually find it in any normal scenario doing the data analysis. So for that, let's go ahead and import a couple of libraries, matplotlib.pyplot as plt, and I will just say matplotlib inline. So we are good here. Now let's go ahead and get the file. So here I have brought the file for you. What I am using is the one which we have already used in several of the videos in the previous examples, just to maintain the consistency. And we are basically reading an Excel file with the help of Pandas function, and this is the path. and this is basically indicating 0 is indicating the first sheet, and we are saving this sheet, which is order information, is into orders. So let's go ahead and execute that. Now it's been executed. Let's see the info related to this. So here we have the information about, this is a row ID, order date, all of those information. So what we are really interested in is creating a pivot kind of an structure for plotting the trend data. So what we want to get is sales and one dimension, maybe either ship mode or region or product category, whatever is one thing, and then basically the year from the order date. So let's create first of all the year from the order date. So what we need to do in that case is we need to write this order year and then simply write orders and name of the column, which is order date dot tt dot year. Well, that's all you need to do. And now if I show you orders dot columns, you will have the year as one of the column, right? So now we have created the year. What we need to do is create a pivot table. So let's create a sales pivot, and we need pd.pivot_table. First of all, specify the dataset name, then the numeric column sales, and then the index to get the rows. So index is basically your year. It was in small, and then in columns you will get, let's say, ship mode. Alright, so here we are with all of this information, and finally you need to specify aggregate function. If I press shift tab, you will see that data, values, index, columns, that's what I have in here, and aggregate function is by default mean. So I'll not go ahead and specify it, I'll just simply use it, and let's press execute that. Okay, so we are good over here, and now let's see our pivot. So here we are with our pivot. Now remember this, that you need to have a certain sort of structure to plot the data set. Sometimes you may not get the expected output because you have not aggregated the data properly. So you can either use pivot table or group by or something else, to aggregate your data. But I find that pivot table is most useful whenever I am dealing with this visualization information. Okay, so I can simply write plt.plot and simply pass on pivot. That's it, right? I'll just execute that, and here is my chart. Now that's the benefit I get it when I create a pivot table, because now my chart is trending. Chart has been created with the trending information, but it's still not complete. First of all, the axis is missing, the label is missing, and let's say you want to use grid, then grid is missing. So first thing I want to tell you is, sometimes this is just an information that there are 3 lines at this particular position. So if you don't want to get that, which is not meaningful for us because chart is the most meaningful thing, what I can use is simply semicolon. That's a trick, guys. So if I execute that, those lines will be removed. Okay, so whenever you are also in a need of not having those lines, that's what you need to do. After that, what we can do is we need to first of all specify the axis. So I will copy this. I hate writing a lot of commands, and I will just say x limit. To specify x limit, though our x limit is properly specified, so but I'll just go ahead specify the lower limit 2009 to 2012, and what I will use is ylim, which is more meaningful because on the y-axis the value is starting from 1000, which is fine, but going up till somewhere near to the 6000. If you see 5706 in the 2011. So what we can do is we can specify the minimum limit and maximize the upper limit. Alright, let's execute that. Now you will see you get much better information because now you even have 6,000, so you know it is somewhere around 5,700 or 800. Alright, once you have added this, now let's add the labels to get the proper information. So what I'll do is I'll just come here and say X label. So label on the X-axis, and let's say sales years, and plt.y label, and we'll say sales by ship mode. So here we are, sales years and sales by ship mode. Now let's go ahead and talk about the legends. So all of these three lines, right now we don't know what they are. So let's see so they are delivery truck, express air, and regular air. So if I go down, and here I just need to add label is equals to delivery truck, and then express air, and then regular air. Go ahead and execute that. You will not see it because we need to add the legend. Alright, so here we are with the legend information, and you can actually specify the position. So you have the value from 0 to 10. So if I specify, let's say 0, okay, I need to specify the argument. If I go and into the parameters, here we are 0, 1, 2, and this is the definition, and it's just that LOC is what I need to specify. There we are. Let's see, LOC is equals to 0. So now the issue is not coming, and if I specify 1, it has gone on the top. So you can basically go into that, pressing shift tab and go down there to see from 0 to 10 what you need to do. So center left, center right, so let's specify center right 7. So here we are. So that's how you can basically add the legend and basically get it done. And there are a couple of other things, like you can specify 7, or you can specify even say upper right. So not only the value from 0 to 10, if you are specifying in a simple English, it will be able to understand where you really want that. Also, there is a way that you can also specify the coordinates. So if I say 0.5 comma 0.5, you will see that it is just looking at the coordinates that I'm specifying. So this is the X and this is the Y, so maybe we need to put little bit inside. So maybe I can say 0.2. Yeah, now it is inside, and then I can play around with that. I can say 0.5 to, let's say, 0.8, and in that case of 0.8, so 0 is starting here and probably going up till here 1, so 0.8 is indicating that you want to be on top. And if I specify 0.2 comma 0.2, it is somewhere down there. So if you want pixel perfect reporting or a pixel perfect legend, not just the upper left, upper right, center and things like that, then you can specify the legends like this and get your legend information as per your need. So that's pretty much about it. It's the very real life example that I have shown you by taking some real data, and probably you will find it useful when you are doing your own analysis. Hi guys, this is Abhishek, and in this video I will show you a quick function to save the plots that we have created in the previous video. So if you remember, in the previous video I created this plot with the help of these different commands to show it here, but sometimes you have a need that you do not want, you want to show it here, or may not want to show it here, but you want to save it for, let's say, use it in a presentation or maybe later use for in some other documentation. So how you can really save the plot and adjust the parameters. So what you have is basically save fig is the one, and specify the file name. So maybe here in this case sales by ship mode dot jpg, if that is the format you want. So jpg, pdf and png is what you get, and png is a default format. So if I go ahead and execute that, it has executed, and since I have not specified a proper path, it has saved at a default location where the notebooks are running. So if I go to the location where all the notebooks are, you will see that sales by ship mode is basically created, and here is the file, the saved plot. Apart from that, what you can do is you can say png and executing it again. If I go back and show you, here we have the png file. Finally, let's see it as PDF, and it will be reflected in a couple of seconds. So here we are, the PDF file. So we have JPG, PDF and PNG. Another parameter that is worth looking at is DPI, the dot per inches. So if I press Shift Tab, you will see the DPI by default is none. So what DPI is basically saying, you can specify DPI as 200, 300 or 400. It's basically saying that higher the DPI is, better the resolution of your image, and it will become more bulky. So you can experiment it with what your requirements are with the DPI, and if it is a complex figure and you want a good resolution, then keep on increasing it until you find the better one. So this is DPI, but you have other like face color, edge color, very straightforward, orientation, paper type, format, transparent, pad inches. All the definitions have been given below. Like I mentioned about the DPI, the resolution, dot per inch, and then you have face color, orientation, whether landscape or portrait. By default, I think it is portrait. And then you have paper type, like in a printing, whenever you print a letter or you want a legal or executive, what kind of paper you want on which the chart should be printed. And then the format, like I mentioned, it has PNG, PDF, PS, EPS and SVG. Yeah, so SVG is also another interesting thing because it does not loses the dots whenever you are stretching it. So another thing on which you can really play around. And then transparent, frame on, box inches, pad inches, and bbox extra artist. So this is something where you can really experiment, like bbox extra artist, a list of extra artist that will be considered when the type bbox is calculated. And if I go back, bbox inches over here, only the given portion of the figure is saved. So it's like very customized plot that you can save for your presentation. So that's about the different parameters and that you can specify, and the different type of format that you can specify with the help of the save figures. So that's a quick one about how you can save a figure, and I'll meet in a new video with a new topic. Hey guys, this is Abhishek, and in this video I will talk about how you can customize some of the font that you are using, or the lines, or the plot is basically to have it more according to your own requirements. So the first thing, or the function that we're going to use is from the plt.rc parameters. So this is the chart that we had created in the previous video. We modified it a little bit, but now what we want, let's say for example, we want to increase the font size. So in the bracket we need to specify font dot size, as you can see, equals to, let's say 15, and execute the plot again. So if I go down and show you, now the font size is 15. Let's say if it is too big, let's make it 12, and again on 12, this is how it is coming. So probably if you think this is fine for you, you can use it. And next thing what we can use is rc params and let's say we want is font dot family, and let's see, we want serif, and execute again. Now you will see the font of the chart has been changed. So you have a couple of others, like if I press tab, font dot, so you have monospace, sans serif, serif, all of these, different one that you can use. Apart from this, so I'll just font family like this and maybe make it 10 so that this is properly coming. Execute it. Font family, adding the quote. So now it is properly coming. And after that, let's say there is a need that you want to change it to a different styles. So there is a style method that we can use, and another method we use is refresh tab plt.style.use, and you can specify style. And style is, there are three ways how you can specify the style, but I'm going to use very directly one of the famous style, which is ggplot, grammar of graphics plot. Let's execute that, and let's execute this. Now you will see that the style has been changed, and it's pretty nice according to the basic ggplot grammar of graphics. There is another style which is very popular from this website. I think it is 538. So let's see, 538. I think that's the right name. Yeah. So if that is a style you want to use, then this is the style. Very similar to your ggplot, but 538 has their own way. So what I'll do is I'll just comment this so that it is not impacting, and I'm just straightforward default using the 538, and yeah, that's the right style. So that's about how you can use the style. But let's say you want to come back to the default, you can use default. Okay, and this is your default style that you can apply. So you can experiment, and then if you want to come back, you can always use default. One other style I would like to show you is the presentation. So that is really helpful when you want to show the plot on a paper so that it looks from a presentation perspective. So if I execute that, file not found, presentation, I think the name is right, PRESENT. Let's go down and see what it is basically saying. Presentation not found in the style library. See style.available. Okay, let's go ahead and see why it is not available. I remember that I used it. Style.available. Okay, so here we are, BMH classic, we have used 538. Okay, I think probably, not sure that they have removed it or what. So you have these different styles that you can then use on the presentation. Maybe that is from the perspective here. I have used in one of the previous videos I have used another function, and I think that was savefig. So savefig is basically to save the figure with the proper DPI and all of those things to put it on a presentation. Probably because of that they must have removed it, so I was not aware. So but apart from that, these are the different ones that you can use. So let's try to use it, maybe classic, and here we are with the classic format. Okay, now let's move ahead and see a couple of other things. Let's try to see something related to the lines, and let me change it to, let's say, ggplot, and and before that I will just use style dot not style RC params, and I want to use line. So you can see that related to the lines you have a lot of parameters to give: line color, line cap style, John style, pattern. Let's specify the line width and make it 2, for example, and execute that. So this is the line width. Let's make it 10 to see the impact. Now you can see with the 10 the line width has been increased. So this way you have a lot of options related to even lines. If you want to come dash pattern and dot pattern, I think they are boolean if I'm not wrong, and color obviously, and marker size if you are using marker on the color. Apart from that, if you want to use the complete list, you just press the tab, and here is basically the complete list, like related to the axis, right? So if you want to use format or limits related to the axis, axis dot label size, maybe you want to use that. So this way, if you have the label size will be increased or decreased. So I think in this case here it has been increased. And apart from that, it's more or less like how do you want to experiment with it, because there are a lot of, so if you are using grid, you have the grid like label color, label padding, title size if you want to work with the title. So pretty much a lot of things which have been given. One last thing I would really I will just maybe increase title size just so that it is working fine, not giving me the error. One last thing I would really like to show you is the configuration file, where you can specify the default configuration that you can use in across the notebooks that you are opening, because by default these notebooks get the information from that file. So for that, what I'll do is I will comment this out, and then I will use import matplotlib as mpl, and let me execute it and create one cell above and say mpl.matplotlib.fname and execute it. So with this function matplotlib underscore fname, what you are getting is this file on this particular location, and the file name is here matplotlib prc. So I think I have opened it. Yes, matplotlib, and I think mpl data. So and matplotlib mpl data matplotlib rc. Yep. So if I double click and open it in a notepad, and here is this file. So this is basically saying matplotlib rc format, and this is the sample matplotlib configuration file. You can find a copy of it in your system, blah blah blah. And if you go down, you will see by default interactive is false, right? But I have shown you in previous video how you can make it interactive. You can specify the time zone, and then line width. By default, what is a line width, what is a line style, color, all of these different parameters that you are seeing. Patch line width, box related to the box plot. If I go down, you will see a lot of other information related to the font, right? So related to font, if you want to specify by default what are the font styles and their stretch, fade and other things are. So this way you can basically update the information over here, but I will be a bit cautious, because if there is if you really want to use different types of styles, and there is no point, but I just wanted to give you an idea about that the file exists here, and you can basically specify what the default properties are in the key value. So this is the key, this is the value, this is the key, this is the value, in that format. And here they have done a really nice job in terms of showing what it really means. So HTML5, video tags and movie writer, a lot of different things with which you can experiment. So that's what I wanted to mainly show you. If I go back to this, so you can use this function matplotlib _fname, which is basically file name, and get the file information. So that's pretty much all I have for you in this video, and I'll meet you in a new one with a new topic. Hey guys, this is Abhishek, and in this video I will just show you a quick information about how you can add text to your charts. So whenever you are plotting chart, there is sometimes a need that on a particular point you need to do a further explanation, especially in cases like when you are not presenting, and especially in those cases like even if you are presenting, you want to highlight with some sort of text that what really happened on that peak or on that tail or downward sloped information. So if you want to add text based on that event that happened on that particular point of that chart, so how you can add that, I will just show you. So as usual, what we're going to use is we were going to import matplotlib.pyplot as plt like always, and then we will going to add this plt.text. We need to provide coordinates, maybe 0.5, 0.5, that means pretty much in the center, and then we will specify the text. This is center, and then simply show. Alright, so this is center, maybe it is not. So this is X and this is Y, so maybe let's change it 0.25. Now it is on this side, so maybe 0.35 is a good idea. Yeah, somewhere down there in the center. So like this, you can really experiment with this about where it should be placed. Let's say I want 0.1, that means somewhere down here on the y-axis, so it has come down. If I want up, it should be over here 1, right? So maybe 0.9, so it's going up. So this way you can keep shifting it wherever you want, and unless you are reaching to that coordinate. Apart from that, if you want to increase or decrease the size, you have the font dictionary where you can directly even apply font size as well. This is center, but if I go here and press shift tab and it says font dictionary, that means the multiple settings that you want to apply in the form of a dictionary, which is a key value pair. So if you go down, you will find the information. Font dictionaries override default text properties. Defaults are determined by your RC parameters, and you have the another parameter with dash, which is a boolean. You can further explore this, and down there you will find some examples as well, like this X, Y, S. S is probably holding some text, and then the font size is 12. So like this matplotlib, even it has parameters which is under kwargs, like horizontal alignment, vertical alignment, transform. So when you go a little bit in depth, like here in this case, bbox parameters stating that face color is red and alpha is equals to, which is the transparency is 0.5, then you can even change the color and make it transparent. So these are the different options that has been given for you to really explore, but I wanted to give you a quick start about how you can really add, and then with the help of this great help by pressing shift tab, you can utilize this information and make your chart more complex, as well as you can read the documentation of text and make it more meaningful. So that's pretty much all I have for you. give you a quick start, and then I hope you will further explore based on your needs. Hi there, this is Abhishek, and in this video I will talk about the scatter plot matrix that you can create with the help of the Pandas library. So as you can see, I am showing you here right now the scatter plot matrix. So on the x-axis, if you see, there is sales, discount, profit, all of those different numerical variables. The same numerical variables you will see here on the y-axis. And the benefit is that in just one simple graph, you are able to see the overview of how your different variables are correlated with each other. So for example, in case of, let's say, this showing a linear relationship, so as you know, the sales and the profit is showing the linear relationship, they are going high. When the profit is increasing, the sales is also increasing. So, or vice versa, you can say that sales is increasing and profit is also increasing, and basically try to see whether any correlation exists or not. So for example, in case of unit price and in case of discount, doesn't seems to be a correlation. Similarly, in case of profit and discount, similarly in case of this unit profit, unit price and discount, like shipping cost and discount, doesn't seems to be a visible linear relationship. Same is the case if you see the histograms. These are all the histograms which are diagonally presented for this matrix. Doesn't show that there is a normal distribution, but they are skewed either to the mostly towards the left side. So how we can basically go ahead and create it within the Python notebook, I'll just show you in a few minutes. Okay, so here we are on a scatter plot matrix. So if I just come here and get import pandas as pt, and to get the plot inline, I will just use %matplotlib inline. So pandas spelling. Okay. After that, let's get our data set. So here we are with our data set, which what we are seeing is with the help of pandas library pt, which is here, read.xl. This is the path of the file that we need to access, and 0 is basically indicating that we want to access the first sheet, which is the orders sheet. And then we are storing all of this data here in the orders object. Alright. After that, let me show you the first couple of observations, maybe just two. Yeah, so here we have the sales, the discount, profit, unit price, all of those values. So if I show you all the columns, I can use orders.columns, and here all the columns are over here. And if I want to know how many total rows and columns which are present, then I can use the shape. So we know that now 8399 rows are present and 21 columns. If I want more information about these different columns, then I can use info function, which will give me that for row ID how many rows are there, whether it's a null or a non-null, and then what is the whether it is a float, integer, date, time, what it is. So some useful functions you will always use in every analysis, just to get the idea about your data set. Okay, now let's come to the business with the scatter plot matrix. So the first thing is saying pd.scatter_matrix, and within that, if I show you some of the columns that we need to fill. So for example, we need to say frame, alpha, figure size, and different parameters, grid, diagonal, by default histogram. All of those options are default present. So let's go ahead and try to create the histogram, the scatter matrix with the default parameters. So what we will do in this case is we will write orders dot loc, or maybe loc is good, fine. And we want all the rows, and then we want columns from let's say over here we have sales, discount, then profit, then unit price and shipping cost. So let's go ahead and write sales colon and then shipping cost, covering all of the. So what it does basically, this scatter matrix just picks up all the numerical columns which are there. It will not pick the ship mode which is coming in between of the discount and profit, and will just show sales, discount, profit, unit price and shipping cost. Even after that, if you would have any variable over here after a couple of object variable which contains the textual data, it would have skipped that and gave us back the numerical columns. Alright, so this is about the basic information that you need to provide. So let me hit shift enter and let's see what it produces. Okay, alright, right here. So here we are with this plot, and here we have our scatter plot. Now the issue is that this plot is not properly sized. So what we can do is we can go back again up there, and one of the parameter, if I show you, after comma I'm pressing shift tab, and the fixed size, I'm using the fixed size to change the size of this figure, and maybe I want, let's say 12,10, and now let me press again shift enter, and now let's see how it is coming. So if I go down, okay, now it's coming a bit better. If I just remove the header, yeah, now all of my columns are coming. So with that, you can basically experiment fixed size parameter, that what is the figure size that you need. Okay, so 1210, maybe you just want 6,10 or 10,6, depends on your requirement. You can play around and get it done. Let's see another parameter which is very interesting. Right now, if you see, for this diagonal representation, we have the histogram, but there is a option which you can change to a more visually aesthetic the diagram, which is KDE, kernel density estimation. So let's go ahead and see that. So I'll just copy the previous code so that I don't have to write it again, or maybe here itself I can change. Now if I say diagonal, by default, if I show you by pressing shift tab, this parameter diagonal is basically histogram. So you can change it to KDE. Let's shift enter. It will take a couple of seconds. Now it is there, and here now you have the KDE, which shows much better information as compared to the histogram about the distribution of data. It's clearly saying that here is a peak, and then we are seeing that when the values are starting, they are at top, but right on this point it is going up to the down. So that basically give us an indication that what's really going on with the data. So for example, here it's a weird chart, and over here it's going up and then finally going down. What's really going over here? Is there any pattern that it is revealing, or any information inside the data that you are about to explore, or you should explore? So that's how you can change the KDE. Apart from that, it has, as you must have seen, if I'm going here, I'm pressing shift tab. Again, it has like marker, basic one, alpha, very basic one, density KWS, hist KWS, range pairing, all of those different parameters that you have. And you can actually go to the documentation of this scattered matrix if you really want to go deep down and try to understand all of these parameters, which basically you can utilize to create an impressive and better scatter matrix. But the idea was that I'm giving you the quick overview of scatter matrix about how you can use it, but I find it very useful. I always create this metric whenever I'm doing any data analysis or any data science project. So that's pretty much about it, and I'll meet you in the new video, the new topic.